I got a range of questions. It's fine.
Oh,
It's okay. And if you guys have any questions that pop up during the meeting, send it to like one of Physoc's social media channels.
That's me and I'll.
That's true. Yeah, chuck them at the back. That'd be awesome. So yeah, and I do. Oh, we also for the people that would like to interact. Today we also have some chocolates. Do you hold them, Johnny?
No, I'm waiting. Thank you.
Do you want one, sorry?
No, thank you.
Okay. Do you want to take?
I'll
Take some for like the pets team.
Good luck.
Sorry.
Monitoring the students. Yes.
Okay, cool. Should I press join?
It started.
Sweet.
It's recording like the best team. So many. So we'll all do great.
Okay.
Statistically speaking.
Okay.
Don't be anxious. Don't be anxious.
Wow. That's a useful
I've actually been first few times.
No, I was second time. I'll pass. Second time. It's like a dumb mistake.
What is the mistake that you're failing?
I think I forgot to submit like the number. Oh, it's okay. Okay, guys, let's just do a really quick breathing exercise before we start. Okay.
Breathing.
Everyone, on the count of 3, we're going to inhale for 3 seconds, hold for 3, and then exhale for 3. And in our heads, we're going to think of one word that is going to summarize our session. Okay, and just say it in your head. I'll say mine out loud. You ready? We're going to inhale. 1, 2, 3. Exhale. Okay, the session's going to be slay. Sweethearts. Yeah, without further ado, let's make a start. How does this question look to everyone? Oh, you guys can't see it.
I realize it's your face.
Should I take it off?
It might be easier just because the plug, I feel like it's not in properly. So sorry.
No.
And that's like 4K as well. Did you want to put the Physoc thing up against the image? Do you think it will?
I don't know whether it will tie up. Like.
Scary. I don't want you guys see my last time. Okay. How are we feeling about this? A gravity question. Gravity question sound good to start. Okay, so this is pulled straight from one of your quiz questions. So we have Newton's law of gravitation here. Before we get started, can I just get a quick spitball of what? Oh, I'm so sorry about what all of these terms mean. First of all, F. Just someone shout it out. Force of gravity. Awesome. What about G? Awesome. Where do I find that? Quality. Sweet as. M1.
Subject 1.
Awesome. And 2.
Subject 2.
Awesome. R.
Radius.
From the center of the two.
Center of mass.
Yes. Okay. It's the distance between the center of masses of the 2 objects. Sweet as. And then what's this N stand for? Awesome. Which is the unit for our force. Okay. Sweet as. We have. Oh, they literally just told you there. C's. That's okay. We also get some information. This might be a really useful lab test technique. This is what I used to do. I always used to write down all the information in a normal exam. When you eventually do a normal exam in your high years, I would suggest literally bringing a highlighter to the exam and physically highlighting it. I'm just going to demonstrate that here by doing this. So we have x equal to a, x equal to b, and that's in meters. And we also know that b has to be bigger than a. Okay, awesome. The first thing we want to do is we want to write an integral expression for the work done by the gravitational force, and we get given our work formula. How do you guys want me to run this? Do you guys just want me to like work through everything, or do you guys want a chance to do it? A chance? Okay, I'll give you guys like a minute or 2 to think about this question / do it.
That's not solid. That feels funny. Well, I knew should. I think. Oh wait, it's like so. Oh yeah, remember just thinking it. And then we just did what's the one. Oh yeah. I believe in you. You did it? Oh my goodness. You did that. Yeah. If I have must be in jam this evening. Does anybody have like a spit ruler or something?
I do.
Okay, thank you very much. Let's see what happens.
Yeah, the techniques is the
It's already broken. It was this already broken with one side. You know what? In the first year, I think I have the other half.
Oh, really? You get this where I broke it.
X1, X2, X1 minus. Yes, yes, yeah. And
I could always go.
You can always just like shove it over.
It's like. Oh, just the things, all the things.
yeah. Like how I. Yeah, see that.
Do you understand the question though? Like you understand what it's asking? Or do you just see numbers and formula, plug it in?
Yes. What are we seeing?
Numbers.
You're seeing numbers and formulas, that's okay. That means that we need to work on being able to translate numbers and formulas into pictures and words, which is a useful skill. And it's also useful to go from pictures and words to numbers and formulas. Okay. Should I start going over it? Or do you guys want a little bit more time? Start going over it? Awesome. Okay, sweet. Before I do that, does anyone want to be brave and spit out an answer? Yes.
Just all of it?
Yeah, can you describe it to me and I'll write as you're going.
Okay, so the constant is gonna be GMM because it stays constant. X1 is gonna be A and X2 is gonna be B. And ways of it differentiating 1 over R squared.
I get another one. Okay.
Who agrees? Chuck a hands up. Chuck a hand up if you disagree. Ooh, now this is gonna be, now you have to be brave, Lachlan. Why do you disagree?
It has to be a function of x, so you can't put r into that. There's an answer there.
That is true. First of all, before we get into why that is true, is everyone okay with C, X1 and X2? Everyone's all sweet. Please tell me if you're not, because it's always worth going through again. Okay, excellent. Yes, going back to what Lachlan said, this is an R and we're integrating with respect to X. So we do need to change this R to some function of X. That's okay. Does anyone want to have a guess at what R might be? Yes, Lachlan.
It's r just equal to x.
It's equal to X. Can you explain why it's equal to X?
Because it's just the distance traveled from A to B, and because you're doing an integral defined on two limits, you just do the integral of that minus x1 minus or integral of x2 minus integral of x1.
What were you gonna say?
Well, isn't that the same thing anyway? Because I'm gonna sub in the same number y.
That's true. That is completely true. So because you're doing a lab test and you're going to be typing this all into a computer, as long as what you're writing makes sense to you, that's okay. If you were in like a real exam, you could write one of two things. You could write, you could write work is equal to negative GMM A to B of 1 over R squared dr. That would be absolutely perfect. It would also be absolutely perfect to write x squared dx. So yes, you're right. Your thinking was completely correct. And you were also completely correct.
The thing with that though, is just that Moodle will mark you wrong for putting r in there.
That's another thing. Yes,
So
we always have
be
to
careful of that.
Yes, yes, yes. Is everyone comfortable with like the Moodle notation and how to input things into Moodle? Okay, excellent. Yes, that is a really annoying thing. Question here.
Yeah, so just to get the like work formula, they just using negative f times d. Like how did we?
Essentially, yes. Work is not just one formula. If you ever go further into physics past first year, you'll realize that work has a whole bunch of different expressions depending on what kind of system we're talking about. Because this is what's given, use this. Is that okay? Yeah. Awesome. And then did you have a question at the back? Sorry.
Oh, no.
Awesome. I will give you guys some chocolates. Do you guys want M&Ms, dairy milks, or caramel koalas? Or do you want me to pick for you? Sure. Pick for you? Sure. Okay. What about you at the back? Koala. Let's see how good you can throw / how good I can.
Thanks.
And then you want koala.
Oh, sorry, guys, I'm really bad.
Okay. Awesome. Okay, sweet as. Moving on to question 2, some of you have probably already read it. Solve this integral to give an expression for the amount of work done by the gravitational force. How comfortable are we with integrals? I'm seeing some nods. Excellent. In that case, I'm just going to do it. If I do this integral, actually, I'll rewrite it. It's negative g and m a to b x to the -2 dx. If I do that, my g and m stays out the front. My x becomes a -1, and I have to chuck a -1 out the front, which will make that positive, and I need to do that from A to B. If I then do that, I'm going to get G and M outside of 1 on B minus 1 on A. I did skip a whole bunch of steps there, so please tell me if you don't understand what I've just written, or if you think it's wrong. Yes.
I don't understand why you
That's
want.
Okay, so let me start again. So I'm starting at this integral here.
Oh, no, never mind. Sorry.
Okay. Is everyone with that? This doesn't matter because we're typing it into Moodle, but to make this answer 100% correct, I can just, oh, kidding, I need to write joules because it's in work. Excellent. And then it's just literally like we've done all the hard work. All we need to do is make sure we put it in Moodle correctly. That's the big kicker. Okay, awesome. And then the last part, part 3. Oh, okay. Sorry. If the satellite is released from rest at B, what speed will it have when it returns to point A? Let's have a little go at that. Oh, yes.
Oh, sorry. Why did you get a positive? What?
Why I got a positive work. Okay, so when I do this integral, I need to increase the power by 1. So if I increase the power, if I do -2 plus 1, what's that going to be?
I'm in -1.
-1. And then I also need to divide by that new power. And dividing by -1, so if I would, is the same as times. Yeah. That clear it up?
Yeah.
Sweet as. Oh, sorry.
Sorry, I understand why work is positive mathematically, but if we're moving to a higher altitude, aren't we losing energy? So are we doing work on the field?
We're doing work on the satellite.
Because isn't that when satellite falls, that the field does work on the satellite?
Yes, so we can do work or the field can do work.
Yeah, when I say we, I mean the satellite. So if the satellite's moving up, it's doing work on the field, right?
Yes.
So,
So
so
field
shouldn't
is
the field work done by the field be negative?
I don't remember what the convention was. I should have noted what the convention was. Do you guys remember what the convention was?
It's a question.
It's positive, isn't it? Sorry?
So
It's an on positive, like if the field does the work,
So shouldn't the work?
does that make it positive? Do you guys know what I'm talking about with the convention? No, that's okay.
Well, actually, no, that would still be negative because one of the.
They've given us the
They've
work.
given us, yeah, so they gave us this work formula.
Yeah.
So what does it say? Expression of work done by the gravitational force.
Yeah, I get what's that.
Just use whatever they give you. I should have noted that down. Awesome. Does anyone have any ideas for part 3? Yes.
Work is just the change in kinetic energies.
Perfect. Okay, awesome. So work in this case, in kinematics in general, goes hand in hand with energy. And in this case, it will be kinetic energy because we're actually physically moving it. Awesome. Do you remember what the formula for kinetic energy was? Beautiful. Okay, sweet as. We can see that we want our final answer to be a velocity. So I'm just going to go ahead and rearrange this equation, and I'm going to get v squared is equal to 2m. 2 over m. Is that always exactly like that? Like work, all of the work is all the kinetic energy. In first year 1A physics, yes. We live in a perfect world. First year 1A physics, 2w m. That means velocity is going to be the plus version of 2w over m.
And you still have this square.
Lol, I do. Thank you. Sweet as. And then what you would do is shove that into the calculator. And then what's the next most important step and a really annoying Moodle thing that we have to consider? Say it louder.
Sig.
One more time. Sig figs. Awesome, awesome, awesome. Do you guys know the convention for sig figs? Lowest. The lowest number, yes, used in the question. Awesome. What is the lowest number that was used in our question? I'm not sure. Exactly. We don't have numbers, which means that we don't have to like put in the formula. Yes, exactly. Put in the formula and be super careful with your brackets and your square root, making sure you write that correctly. With your fraction, make sure you write that correctly. Yeah. Are we chilling? Was that a question? Sorry.
Is that the final answer?
Yes, you just have to type into the.
You have, you need to sub in the.
Oh, yes.
Yeah, wouldn't that
Sub
ask
the
you
work.
to?
Yes. Do you guys want me to? I'll just do it for completeness. And then I'll do this. Is this tool that I have?
Do you have access to the answers? Can I actually see the answer?
Yes, I think. Over M. Sweet, that's just 2g times that, so it'll be here. Be one of these. So they just took the root 2 out.
The m that's cancelling is the m of the satellite, right?
Yes.
Well, they changed the A's and B's around as well because that's negative.
Yes, and that's okay because maybe we just make the question properly. So in the solution, they said A comes first, B comes second.
No, I think it's because if B comes first, your work will be negative and you can't square root it.
So again, yes, convention, that's true. Yes. Hang on.
And it's saying it's like from rest at B. So
And
you're
it's
going
root
from
A.
B to A in part 3, rather you're going from A to B in the other part.
So we're going from B to A. Wait, in the second part, we go from B to A?
In the third part, we go from B to A.
Oh, well, yeah. So that was all fine. Which, yeah, literally just means that you can swap these bad boys around. And we got A to B. Sweet as. Do you guys want to try another problem on gravitation, or do you guys want to do a different kind of question? Yes.
Can I do rods?
Like moment of inertia on rods?
Yeah. Especially the ones with multiple densities. Like made from multiple materials.
Yeah.
They have like a compromise.
Yeah. Is that lab test?
That has one.
Lab test 1. Let's see if I have a question like that. Okay, down here. This is here.
Yeah, that's this question.
Sorry, I actually have a question here. I think it's the question what she was asking. Like it was like this.
Okay. Do people know the question that we're talking about, or should I try and get it up?
Like there was this what question where it says like different materials and
Is that like where its density changes with as a function of L or something?
Yeah.
Yeah.
Do you want to try and send that screenshot to even chuck it on your Discord even? And I can get it on. If that's okay.
Like,
Would you rather not?
I don't know. I don't think I'm able to send a message.
Do you want to like airdrop it? This would be helpful. So yeah, multiple density moment of inertias. What else? Yes.
There was also this question where a ball with a radius goes down a ramp and then it goes in a circle in a loop.
Yes, okay. You have that question as well?
I'm not sure.
Okay, okay.
Can I airdrop you the picture like now?
Yes, is my iPad coming up? Just go. And then, do you have those questions easily accessible? Do you want to try and send it to
Yeah.
someone from Physoc, one of our social medias, or my downloads? My computer airdrop is just called Anna's Mac.
I don't have a Mac. So.
Oh, sorry. Yeah, do you have Discord?
Yeah.
Awesome. If you could chuck it on your Discord, then I can also get it.
Yeah, there's one There is. You did it fill yet? What?
Quickly check.
You have much time. Let me just quickly see if it's
Just like.
I only have 3 times.
It's like.
Yeah,
Lost
one
it,
the
then
29.
I think it's fear then. Maybe. Had the time to like.
Okay, so this is the question that we were talking about. Has everyone seen this question before? Awesome. Again, let's start off by spitballing everything we know about moments of inertia. What do we know? Do we know a formula? Do we know what a moment of inertia is? Do we know what it's not? Yes? Do you have anything to say about moments of inertia? Or you just like
I
kind
know
of?
I did put my hand.
Yes, okay.
Like integral of R squared dm, but dm is like that's not dm isn't super helpful, so we have to convert it into dx.
Awesome. So dm might need to go to dx. Anything else about moments of inertia? Is the moment of inertia always the same?
No, different.
Awesome. So I'm just gonna say MOI different or different shapes.
Would it also be possible to relate to center of mass? Center of mass?
You go over center of mass?
No, like, would it be related to center of mass as well?
Yes, but I would say it's related to the center of mass in the sense that it's related to the density of the object, linear density or the volume density. In this case, we're talking about a linear density. So the density of an object, if it changes, it'll affect where the center of mass is, which will then have a direct effect on the moment of inertia. Is that sweet? Yes. Excellent. Okay, cool. Does anyone know anything else? No? Neither do I. Excellent. Okay, let's move on to the question. So we have a composite rod and it's made from 2 different materials. One part of the rod has a length of that, the other, and it has a linear density of that. The second part has that length and that linear density. The rod rotates about the junction between the 2 materials. Consider a small increment of metal with linear density lambda 1. What is the mass of length dx of this material? Does anyone at all want to have a go at trying to either give me an answer or trying to explain an answer? There is no expectation that you guys are right about this. I'm just looking for anyone to guess. Yes.
You could change R to be the linear density multiplied by 101. I don't know.
Does anyone want to finish that?
By the mass. Sorry.
Anyone want to contest that? contest this statement? Let me just have a think about it.
Is the distance from 0 point?
Yes, from the point of rotation.
Mass divided by the density.
Mass divided by density.
Because density is like mass over the, like, by definition. So then like this, the mass divided by the density.
For R, sorry?
Yeah.
Yes. In this case, do you guys use rho for density?
Yeah.
Okay, excellent. So because we're talking about a linear density, it's going to be mass over, I'm talking about length. That's what my L means. So that'll be rho. So what is your expression for R then?
Mass divided by.
Awesome. Oh. Like that?
Yeah.
Okay. Anyone have any thoughts? I'll say lambda 1. Say R1.
Why do we need to change R for N?
Change R.
So why are we trying to write R in terms of? Is that usually that we write dm in terms of dx? Physical density.
Yes, that's also the way that I know how to do it. Oh no, yes. So what do you think it is then?
It would be the same, it would just be dx equals dm on lambda.
Dx is equal to dm on lambda 1. That's another way of thinking about it as well. Awesome. So that's for R1. What about for R2?
It's the same, just with.
Awesome. R2 is equal to, this will, I just write ones, M2 on lambda 1. If we think about this, we also get on lambda 2. Awesome. So if I were to construct my integral, or like my resultant integral, what would it be? Sorry, did someone say something?
Integral x squared times lambda dx.
Does anyone want to contest?
It's from 0 to x.
How are we feeling about that? Thoughts on that?
Do you have to, with your bounds, do you go from 0 to x, 0 to L? Like, do you, that doesn't make sense. Like, do you do the whole rod or like half the rod?
The moment of inertia.
Yeah, it's rough.
Yep. Wait, sorry, what did you say?
Oh, like I always get confused with the bounds. Like, do you integrate from 0 to L1 or is it,
Oh no.
or like 0 to x?
No. Oh, we're back. You get confused if it's from 0 to L1 or 0 to X.
Yeah, or like is x to L1? Like, what's your like upper bound?
I'll just give you the straight up answer. It doesn't matter in your calculation. In the final question, we do want to know what the total moment of inertia is for the whole rod. So you will need to plug in x is equal to L1. It's okay if you write 0 to x, as long as later you remember to plug in the number for x. In this case, it'll be L1. Or you can just integrate straight up from 0 to L1. It does the same. Does that make sense? Okay, awesome. So let's consider a small increment of material density. Where's the mass of a length dx of this material? Awesome. So are we all sweet with this answer then? I see some nods. Does anyone want to shake their head? No? Okay. In that case, we can move on. Oh, this is feedback as well. To part 2, what is the moment of inertia of the part of the rod with linear density L1 about the junction? Do we know what all those words mean? Do we know what junction means? Beautiful.
Oh, sorry, I actually don't know what junction means. Is it like the
Totally fine.
point where like right in the middle, like where
Where they meet, yes. In this question, it's also rotating about that point.
yeah.
Awesome, perfect. There's literally in this session, no dumb questions. I remember in my first year, I literally asked in front of a whole lecture theatre what the units for voltage was. It happens to all of us. It really does happen to all of us, so it's okay. Going to part 2, I kind of like, are you guys okay? You see the working and I kind of explain it to you because I can't like, unless you guys want to try. How would you guys solve part 2? Solve the integral, awesome. And I think that you have already done that. And it's also here. So you want to chuck in the r squared dm and you're gonna rewrite r squared in terms of x and lambda. And then it's just an integral. Is everyone okay with that maths as well? Okay with the calculus? So it does. It's a good thing. So move on to part 3. What is the moment of the inertia of the composite rod? Moment of inertias add up. So if you have 2 different densities, you just add the individual moment of inertias, like it says right here. So you would calculate the other side of the rod, the moment of inertia for it, the exact same way as you did here, except with L2, lambda 2, sorry, and also L2 up here. And that'll look like this. And then what would you do? Sub in values and then make sure.
I'm gonna say significant figures.
Significant figures. Yes, yes, yes. Do you want a chocolate? Sure. I'm just gonna give out a round of chocolate because I've definitely missed people. Yell out what you want.
As long as it's chocolate.
Not plain chocolate. That's the most like chocolate. What would you like? Caramel. Let's see how the macaroni is. Oh, a bit higher density. Who else? Who else just wants a chocolate? What would you like? Dairy milk. Dairy milk. Let's see how good I am. Yes.
Koala.
Koala. Let's see how good this is. Anyone else?
Yeah, I'll have a koala as well.
Oh, it's so popular. Oh, well, it's kind of bad. Anyone else? Dairy milk. Wow, dairy milk also. Oh, my bad. Sorry, my bad. Oh, sorry. Thank you. Oh, sorry. We changed the balance. So the way it's right here. Yeah.
Like a miniature mass.
Yeah. Are we all sweet with that? Yes.
This is a bit of inertia. Are you literally just adding up the 2 sides?
Yes. Yes. So moment of inertia is add. Do you guys remember your moment of inertia lab? So it's kind of the same thing, kind of almost. In that lab, you measured the inertia of just the plain rod, and then you chuck 2 masses on the end of the rods. And do you guys remember, or maybe your results weren't matching up with theory, but what did you guys find in general? What happened to the moment of inertia? It's okay, don't worry. It was a long time ago. Don't worry. Don't worry. Are you guys okay to move on to the next question? David, do we have? No? Sorry?
No questions.
Someone have a question that they wanted. Didn't we say we wanted to go over another one? Did you have a question?
I thought someone.
Oh,
has
sorry.
a question.
I'm trying to send it now.
That's okay. Are you sending it on Discord or another way?
Well, I'm on as well. Can I send it on Discord?
Want me to take a photo?
I can't see
That would also work.
Just, oh, you just,
Yeah.
you just.
Yes. Anything? We can scroll through the questions I've prepared and do it. Some of them. Kinetic energy
Rotation, sorry.
with rotation.
I don't know. I never.
Um, So kinetic energy with rotation.
I don't think.
You have an example, because I don't know what you mean by kinetic energy with rotation.
I don't think.
Rotation.
Unless it's like half m omega squared.
Yeah, that's the half inertia. I mean, this.
Half inertia omega squared, and that's rotational kinetic energy. Can't think of any question.
Can we, do you have questions on pulleys where we consider the mass of the?
On pulleys, I do. Let me find it.
Oh, actually, that's one of the ball would be good.
Sorry.
The one with this,
Balloon.
no, the one. The ball.
Sorry.
Yeah, that one.
This one. This bad boy. Oof, ramps. Love it. Okay. Let's do this question, and then if you guys can chuck it on the Discord, that'd be awesome.
We just put on his,
Is it your one or is it the Physics Society one? Oh, you can chuck it in there. Yeah, I'm on that one. I can access it there. Okay, awesome. So let's have a look at this question. We have a cylinder of that mass with that radius and it rolls down a slope that has that height. And it's inclined at that degrees. It starts from rest at the top of the slope. When it is rolled without slippage down the slope, it has a speed of that. At the bottom, you may use this moment of inertia for the cylinder. Awesome. Let's have a go at calculating the gravitational potential energy. Does anyone want to spitball what gravitational potential energy is? Ooh, good question. Should we chuck in a negative sign or no?
depends on which way you reckon is the point of
Yeah.
This potential energy. Oh, I guess it does have direction.
Yeah. The way I would answer this question is with another question. What does it say on the formula sheet? For like small distances, right? Because
Yeah.
when you're talking about massive distances like between galaxies, that's the one where it's G/m/r with a negative out the front. For small distances, we just use mgh. That makes sense. Yes, sweet as. Hopefully, if you did that, you would have gotten whatever 8 times 9.8 times 1.71 is. Yep, chilling. Let's just essentially keep that in mind. We might use that later. Awesome. For part 2, what is the net force on the cylinder halfway down the slope? Take I as the unit vector parallel and down the slope and J as the unit vector up and perpendicular to the slope. So it's saying that this is J and this is I. Awesome. We want the net force on the cylinder halfway down the slope. How are we going to do this one? Free body, awesome. What are my forces going to be in my free body diagram? Yes, which way is gravity going to go? Or gravity downwards, we call that the weight force. So let's just call that down. How do we express that? Say it louder.
negative mg.
Negative mg force. Okay. Awesome.
Do you need the negative there if your arrow is already pointing down?
That's true. Yes, you don't need the negative there if your arrow is pointing down. You also don't need the negative there if you take G to be negative 9.8. So yeah, it's just a convention thing. I won't include it because I never really do. And we also do have the arrow saying that it's down. I will also take the gravity when I'm considering my vertical or my perpendicular and parallel directions. I'll take my gravity to be negative. You also said friction.
Because there's no slippage.
Awesome. It says no slippage. So that means that we have no friction. Sweet as. Just highlight that. Awesome. What else do we need if we want a free body, if we have a free body diagram? Normal force. Awesome. And then do you guys remember that's do you guys remember the equation for that?
Mg cos theta.
Perfect. Do we know how to get to mg cos theta?
Is it always
Parallel thingy.
It's always cos theta for this kind of triangle.
If the theta is there
then it's comes
Yes,
plus theta.
so if I break up my this vector, this theta here is going to be up here as well. If I take the cos of this theta here, so if I literally just do cos of that theta, I'm going to get the adjacent. So this is my adjacent here, and that's going to be my normal force, or the negative of my normal force, but let's just look at the magnitude over my hypotenuse, this one, which is mg. Again, just a magnitude, which then implies that n is equal to mg cos theta. Cool beans? Cool beans. Awesome. Yes. So we have our two forces. Do we have any other forces? No. Awesome. Sweet as. So going back to the question, what is the net force on the cylinder? How are we going to calculate this net force? Sweet as. How do we want to decompose our vectors? Yes. Yes. What I meant by that question is like, are we doing horizontal, vertical, perpendicular, parallel? You think horizontal, vertical? Does anyone think perpendicular, parallel?
I think also you vector, but it's not. So the vertical vectors are cancel out, right? So by vertical, I mean the ones perpendicular to the slope.
Yes.
So then isn't the only vector we need to consider the one that's parallel?
Yes. So going back here, because the question says to take where does it say? Where does it say to use? Yeah, take I as the unit vector parallel and J as the unit vector perpendicular. So we're going to be thinking about perpendicular and parallel. And then going off of what you said, yes, the only resultant force is going to be the one parallel to the slope. So what does that mean straight away? We can input for our vector J. 0 straight away. Don't even just think about that anymore. Awesome. So now we just need the force when it's halfway down the ramp.
Why were you able to cancel it out? Why were you able
It
to
doesn't stay.
Cancel what out?
J?
J?
Oh, just because it doesn't do that.
Yeah, so if this is J and this is X, is the ball sinking into the ramp or flying away from the ramp?
So it's just zero.
Yes. Is the ball going down the ramp? Yes, so that's why it's only, the only force acting is the one going down the ramp. Did that clear that up?
Yeah.
Okay, awesome. So yes, now we're going to decompose the vectors. And we've already said that the only vector that really matters is the one down the ramp. What is the vector down the ramp? I'll call that one F just because the answer you said. So what is my F going to be? Yes.
MG sine theta.
Awesome. Do we know how to get that? Does anyone not know how to get that?
Opposite and the.
Perfect. So the same way we did the cos theta one, except this time with sine. So we're going to take the sine of that angle. So we end up getting mg sine theta. Awesome. I'm pretty sure, yes, that to input this answer, we literally just need to do like 8 kilograms. And what do we always do in Drupal regarding units? When we think about significant figures, what kind of units are we going to use?
SI units.
SI units. Is kilogram an SI unit?
Yes, it is.
Awesome. Gravity is 9.8. We'll consider direction in a second. And then sine of 49.1. Always make sure your calculator for these kind of questions is in degrees. That could be another point of error. That's just degrees. And then my units are newtons. Awesome. Yes, so we'll get an answer. What is my final answer in here going to be? Is it going to be positive or negative? Awesome. And why?
Because it says take I, it's parallel and down.
Awesome. So sorry, my bad, it goes in there. Awesome. So it's going to be positive number down the ramp. Does the force down the ramp change as it rolls down the ramp?
No, awesome. So that means that the force down the ramp is going to be always the same or like the same size or have the same magnitude all the way down the ramp. Excellent. Are we all sweet with that? Cool. Part 3, what is the coefficient of static friction between the cylinder and the plane?
It's the whole question.
Well, that's the end of the question after part 3.
Oh, what was the point of telling us to take this as a way that should?
What was the point of telling
Because
you?
they gave us a following information, right?
Just a throw us off.
Yeah.
I remember this question being way harder to like.
There probably would be another similar question, yeah.
So with the force, what's my positive of your?
Yes, because in the question, it literally tells us to take the y, like in this direction, as being positive.
Okay. Yeah. But, is this?
Chilling, not chilling. Did you want another chocolate?
No, it's okay.
Okay. Does anyone else want another chocolate?
Cool.
Well, this is gonna be a left-handed throw, so be ready.
Parallel. That was just fine. They just. Yes, they're fine.
That question, I think that.
It says in the second part of the question.
I didn't realize
that question.
I figured it out.
Sweet as. What about part 3, the coefficient of static friction? If you remember, you guys would have done this formula in your lab. It's okay if you don't remember. But how would you calculate the coefficient of static friction? You don't remember. Say it louder.
friction,
Is that right?
Sorry?
F friction over F normal,
F friction over F normal.
but I think that has to be like maximum. That's a max static friction coefficient.
Do you guys want to tell me when do we apply static friction and when do we apply kinetic friction? Yes, also if we're not moving, that's because static friction is like holding us back. If we are moving, there still is friction, but it's kinetic friction. Awesome. Do you know like what limit or what instance we have to consider, what condition we need to put in place in order to find mu s?
The maximum theta, like the angle, like how big that's.
Yes, but going back to the question, it says it starts from rest at the top of the slope. When it is rolled down the slope, it has a speed of 4.73 at the bottom. Hang on, is that going to be useful to us? I find it useful to use that.
Find the energy box.
Yes, you can also do that. Just for the sake of time, do you want me guys to re-remind you what the formula is?
Yes,
You
please.
said it before. Yes.
10 theta.
Say it louder.
10 theta max.
10 theta max. In this case, it tells us
It
what the
is.
theta is. So yes, you can literally just chuck in 10 of 49.1 and you should get a number between 0 and 1 and we should be sweet. Is everyone okay with that? Just because we're at the end of the first hour and I think a lot of you are here for lab test 2 as well. Yes, so you guys all sweet if I just tell you mu is equal to 10 theta. You guys are, I don't
You can
remember.
actually derive it.
You can also derive it very easily.
Because because the friction force is just the minus normal, and technically normal should be minus mg cosine theta because g is acting down. So that just becomes mg cosine theta over mg sine theta because that's the normal force, and then you cancel out the mg's, you get tan theta.
Is that for all cases?
Of an inclined plane. Yeah.
So which goes to mu s is equal to the mg's will cancel. Mu s is equal to sine theta on cos theta, which equals tan theta.
Oh, yeah.
Did you have a question, sorry, at the back? Sorry, what was your name as well?
David,
Yes.
I don't know.
Oh, sorry, the person in front of you. Did he still have a question?
No, I thought you said 10 theta is in the number.
Oh,
so sad.
Sorry, it's 10. My bad, my bad, my bad. Would you guys like to have a little break? A little break? Or do you guys just want to get straight into lab test 2?
Maybe 5 minutes.
Yeah, maybe 5 minutes.
5-minute break? Okay, awesome.
We'll get our friends to come.
Yeah, chuck your questions in the Discord, or if you can find my laptop, it's called Anna's MacBook Pro. Chuck it over.
Where's wait?
Newcomers like some chocolate.
Please have a chocolate.
Yeah.
Thank you so much.
You guys like a caramel color, a dairy milk, or a M&M? Would you like one? Damn, sorry. Tolerance. Davide, you're even lactose intolerant.
I mean, to me, bad just as. So.
It was big.
Wait, can people remind me? I got a lot of thermo response when I asked on the Instagram. Are we good to do thermo?
Yes, please. Yeah.
Send me any specific questions you have for thermo, otherwise I have thermo specific questions.
I think she can't share. You do, right?
Wait, is it after this?
It's because wait, you can answer. No, you explain.
Someone send you question.
Like, what are you going to be able to see my invitation?
You will.
Sorry.
We're doing 4 hours, but that's not now, you know, you both stop down. Yeah.
You guys gonna go to work?
When it was starting to go.
Hey guys, do you guys want to sign in?
And have you figured out if you're awake for lunch?
Not yet.
Also, I couldn't find any of the Easter eggs. So. The downgrade.
I don't dominate these. Oh, who else is? Let's go.
I rose. What can you do with the idea?
People go? Oh, people go. I'm not like going. It's like, you try that chair, someone back.
Yeah, sure.
One that I promised, but.
Oh, it's like one of the.
Yeah.
Okay.
You're the small girl.
Yeah.
Something.
Absolutely.
Alright.
Yeah, we doesn't pay. So then. I'll just assume
That's what the
Okay,
first.
alright, I'll go.
Oh, the first one.
Yes.
Oh, yeah, sure.
What about it?
Yes, then.
How many?
At 6
You
p.m.
the.
At 6 p.m. Regent
Yes,
Hotel.
yeah, I'll see my enough, because I'm just like.
Okay, we're getting together.
That's because so many people have asked.
Yeah.
Well, why not? It's
Yeah. Going
Because I can just people like, hey, come popcorn.
You've.
And I'm like, oh, Regent Hotel. Okay, I'll go. It is.
Yes.
We need better first year turnouts to be the best. You guys need to come.
Explain that.
My first year.
Yeah, I'm just saying.
This popcorn is gonna be really big because we're doing it with 12 societies. Normally, like the pure fizz soft popcorns are like iconic. Wild things go down. Wild things go down. I won't say because I'm being recorded, but. Oh, I mean, that's yeah. It's so cute.
So.
But
You kind of give off like.
Actually,
Sorry, would our newcomers like chocolate?
and then I
Just go get a
We have caramel colors, dairy milk.
Yeah.
They're paper cups.
My memory. Someone told me they went to cherry book. Papers and things. So. You want to just want to get one goal.
okay.
Yeah.
Actually, because I don't have a point.
That one's for the
I
right.
do say save this.
No, I'm going to have.
Oh, yeah. Oh, yeah. Just
That's asking a question. I'm like, bro, no, I'm like, I go like throw the stuff in. It's just like rubbish. Velocity, and then like rotation was like in my pen. I was telling them for I was so tired today. I was making such a good idea. Oh yeah. Oh, wait, that's
Okay.
It is, but I don't know how to.
What?
No, see that now.
Yes.
I haven't seen it.
I've got to get my tail slide. This is like.
No, I mean, this is all, it's.
Don't have it.
Hello, you guys want some chocolate?
Got like another chair.
We have, is there another one or is it empty?
It's empty as a rubbish bin.
Oh.
You guys.
Oh, that's now. That was your new one. Oh, I didn't do it. They said it's like too much long experiments. I did a lecture on the vacuum instead. But that's, yeah.
That's
It's my favorite. Yeah. That's why it's staying busy. It's like you.
You guys want some?
I like your shitty first few experiments. Oh, that's a I'm doing experimental physics.
What you said it's pleasant.
Good idea. Optics basically. You know, like radio, you modulate the. Yeah, oh yeah. Something by the way.
Oh, actually.
You modulate the amplitude of the electromagnetic wave. In this case,
That's way too hard.
so you like vibrate crystal and it modulates it. And you get to play a song with.
That was really hard.
Doing that wrong.
Because like the laser goes through and spread it out.
No, I was.
But I also do,
I was
putting PV to the
So
ground
basically you work with
in all
rainbow.
brackets and I was getting it wrong for like.
Electron diffraction.
I saw you using it.
You guys.
Oh, yeah, and I put it in
double.
Yeah.
Yeah, electron diffraction.
or anything.
You do that in a lab. So you get little rings, and you like measure diameter.
Yeah, so all of it.
So
It's like,
they're all very
cool,
cool.
it's like, look at an atmosphere. So I was like, oh, how fun.
I love electron.
Depends on, sometimes like in the real world, you might use atmospheres, but that's because the K constant is in terms of atmospheres. So on the formula sheet, the K term is in terms of pascals, so that's why we have to use pressure in Pascal.
It really so we don't have to change K. I like little planes. What do you mean? That's so much fun. Actually, if I'm kidding,
That's just on the.
that's what I did. It's they choose to cancel it.
Well, this is the right question. I obviously.
I like stack a bunch of books on it. Like, yeah, it's such like a voice. I just like rolled like a party. Like that. It's like really weird.
Yeah, that was temperature was.
What's the password?
I mean, I guess it's like a high function on cheese.
The question is gonna. And it wasn't even.
You guys want to know about my like fire nuts? Look to me, I'm not gonna.
Wow. I'm not saying but then I don't know if I'd be committed enough to like.
Where would a great place to talk to you be, perhaps in the next few hours?
Use it.
At the roundhouse.
Yeah, no.
Or at 5 o'clock, you can go to roundhouse or pub crawl after.
I have a question.
Oh, that's it.
The meeting in the room.
This.
Are you going to the roundhouse?
I'm gonna go over it.
Should I go anywhere else?
But at least I could send the.
I mean, what else?
Even like, are we on?
Go
You
home.
wanna try?
Sleep is good. Sleep is always good.
Yes. Can you screenshot all this and pop it somewhere on there? Or wherever the meeting's gonna be. I did not.
Oh, these are different ones. This one is everyone's putting the ones that they already have, like
Just
the
screenshot.
names and it's like.
Yeah, even if you do that, that's very
Yeah.
hello, everyone that has now joined us. Are we all good if we start like the lab test 2 part of this revision session?
Has anyone not done this QR code, by the way? Oh, yeah. Yeah. Me has to do that.
So in my Instagram post this morning, I got an overwhelming number of responses that said thermodynamics. Does that still hold? We want to do thermo? Chuck your hand up if you like thermo.
More than mechanics for sure.
Controversial. Wait, chuck your hand up if you're an engineer.
That makes sense.
Chuck your hand up if you're actually a physicist. Okay. Oh, we got some engineers and physicists. Well, just so you guys know, in your third year, you'll do a course called thermodynamics and statistical mechanics. And
Oh my god.
oh my god, it's so much fun.
Like some steroids.
Oh my god, guys, you don't understand. Oh, but you will. It's okay. It's a beautiful thing. It's a beautiful thing, guys. Think about this. What's like, if you guys could have one thing in the universe, what would it be?
What?
$1 million. Do you guys want $1 million? Think about this. $1 million is not going to keep you warm at night, but thermodynamics will.
Oh wow.
Just saying. Just saying.
It's like a reason.
Tell me I'm wrong. Tell me I'm wrong. I dare you. Anyway,
No, so keep stuff cold.
That's good, that's good.
Anyway, it works both ways. It
I
works
don't know how
both
that sounds.
Anyway.
Sure.
Anyway,
We're doing physics here.
Yes.
So this is the question that I have prepared. Would you guys like to try this question? I'm seeing no one shakes their heads. No one is shaking their head, so I'm taking that as a yes.
Cool, just go for it.
I hear a sure. Okay, let's try this question. So we have an ideal diatomic gas undergoing 4 processes: a rapid compression, an isothermal expansion, and an isobaric and isochoric process. And then it gives us some numbers. What are the important parts of this question that we should probably highlight straight off the bat?
Isothermal.
Yes, isothermal is important. Anything else important? Just fill it out. Rapid compression.
Temperature.
Temperature, let me just find that. Temperature of the gas is this one. Yes. Anything else? Moles. Awesome. We have 1.16 moles. Anything else?
Ideal gas.
Diatomic and ideal gas. Exactly. In first year physics, all gases will be ideal. So, diatomic is a big kicker. Can you guys tell me anything about a diatomic gas?
Equal to.
And then louder for the people in the back. What'd you say? F is equal to?
3, 5, 5. It's fine.
It's on the data sheet.
Yeah, it's on it.
And everybody like this struggling with it, and I was like, oh, but it's on the
Awesome.
Oh, wait, hold on.
Oh, lol, I don't
Yeah,
have my
because it's,
question.
wait, from less than 100 Kelvin, it's 3. Yeah.
Yeah,
100
see?
Kelvin.
But as
Well,
I'm
I'm
not
not
it's
Yeah, I do.
still have to think about it.
I'm good.
Yeah.
man. How are you? Good to hear.
Oh,
It's
oh,
probably.
I don't have the caption. We have to do another question. It's similar. It's similar. Don't worry. It looks the same. It looks the same. My bad. My bad.
It's okay.
How do I delete? Where's the trash can? Let me just paste on top. It's fine.
There's a cross in the corner.
There is this thing. Okay. Then let me do this. Aha.
Wow.
Let me just speed run this. Okay, we have an ideal diatomic gas still. It's at this temperature. We have a pressure. We have a volume at A. We say that the vibrational modes are not excited. Don't worry about what that means. You will in third year though. Third year. Oh, it's a beautiful thing. Anyway, the gas is rapidly compressed. We have another rapid compression. Does anyone want to tell me what that is secret code for?
Adiabatic.
Perfect. Everyone's favorite process. No, I'm kidding. That's actually a good question. Yes.
Sorry, can you scroll up?
My bad. We have an initial volume, a final volume. That's probably also really important. And we want to find the pressure of the gas immediately after it is compressed. Okay, cool. Do you guys just want to, oh yes.
I just want to ask for the diatomic gas here, right?
Yes.
Is that F5 or 3? Because on the formula sheet it says 0 to T to 100 K.
For a diatomic? Yeah.
That's
I'm
what
not
it
sure.
is.
But this is
Yeah.
That's.
Oh, then that's 100, so it's 5.
So 5?
Sure. Yeah, it is 5.
Yeah. You guys know I just might need refreshers on what the first year equations are because third year equations are different and they're more beautiful, but that's okay.
That's great.
Yeah, anyway, let's have a go at doing part one. Does anyone want to send us or at least put us on the track or what they think the track might be? Yes. Oh, okay.
PV gamma equals PV gamma.
One more time.
PV gamma initial equals PV gamma final.
Awesome. So I'm pretty sure was also in one of your pre-lab questions from the other week. P1 V1 to the power of gamma is equal to P2 V2 to the power of gamma. So
Why do you need the gamma then? The gamma. You need
that's not how that's controversial.
P is to the power of gamma, not PV.
Yeah, it's this.
Yes, that's a very good point. This P1 V1 to the power of gamma is not the same thing as P1 V1 to the power of gamma.
Yeah, but I'm just saying, isn't P1 V1 equal to P2 V2? Like, you don't need that gamma.
No, it's not.
Because this,
It's like the initial two. No, this is.
so the thing that you're thinking about, Lachlan, is PV to the power of gamma is equal to a constant. So that's equal to a constant.
I've definitely used P1 V1 equals P2.
That's a different sort of.
So this is
Different question.
Okay. Oh, okay, right.
So like isothermic.
Gotcha.
And no.
Okay.
Yeah.
I think we need to
But
use
it's
the space of the
the
front as well.
Yeah.
We can lab. Everyone was running isothermic. Yeah.
So what are we gonna do in this question? Let's not overthink it. What are we gonna do?
Gamma is N over.
Yeah, and plus two over.
Yes.
Yeah.
Thinking of plus
And plus two, right?
So, and if I make that substitution, I'm gonna get.
I did leave and then I did come back.
Oh, I was not paying attention.
Yeah, we're gonna like, it's like we don't.
Yeah, because you have V and V, so you just.
Yeah, I'm just like, I'm so gonna elbow this like in so many times.
The gathering strong.
Sorry.
Yes. It's the. We need to find.
I still got the.
Yeah. We need to find. Yeah.
There is a seat.
Someone back.
What's my next step gonna be?
Rearrange the equation.
Awesome, perfect. I'm looking for PV. I'll just change this quickly. This is a.
Just divide by the second volume to the.
Actually, yeah.
Well, that's all you do.
Just use.
You can find read out and then you do is gamma rays.
Wait, didn't it say the pressure?
Isn't it just B?
No.
Gamma.
We're talking about a rapidly compressed system, so it's adiabatic if it's rapidly compressed.
No, it's not asking about inventory.
Oh, no, that was the last one.
That's B.
Yeah.
No, sorry, you're. Yeah, we don't, we need to find this.
Awesome. So are we all good with that first part? No one shakes their head. I'll assume we're all sweet. Yes.
I want to ask, in the question, it mentioned atmospheric pressure, right? What does it stand for? I see letters, like, or does it matter?
In terms of units, you mean?
Like, you know, like, they use different letters in forming this room. Like, what will that be? Is it BA or is it B?
Oh, that's, yeah, I see what you mean. The reason why we talk about like atmospheric pressure is because the constants that we use to like are in terms of atmospheric pressure. They're in terms of pascals. That kind of makes sense. We'll see if we need to use it in the next part of the question. Normally they'll chuck it in there because eventually we might need to convert to atmospheres and pascals. So that's we might at A. Not unless it says, but it doesn't. No, it doesn't say P in it. Yeah, so that means pascals. PA means pascals.
It says and because a lowercase a as well after the P.
We also do that. PA in this case is pascals. Sweet as. Okay, moving on to part two. We want to know how much work is done on the gas to compress it. I feel like this is a question that a lot of people maybe struggle with. Am I correct in assuming that? Yes, okay, awesome. That's okay. Do you guys want to give it a go? Or would you like me to like start off right off the bat?
It's the NRT will be.
Oh, are we still going on?
Yeah.
Because we've got that equation. And then dawn of the P final load. Oh, nice.
Can I just get hands up? Who wants to try this question before I do it? And who wants me to go just straight into it?
Probably straight.
Okay, okay. I'll just go over slowly and you guys can listen in or try it on your own. So up the front, we said that we're going to be using our very famous equation for an ideal gas. PV is equal to nRT. Is that familiar?
Yes.
Awesome. Do you guys ever use this one? Or like
Yeah.
N?
That's the, yep.
Yeah. Do you guys both familiar? Which one do you guys use more? NRT. We'll use that one today. Awesome. And we want to find out how much work is done on the gas. In the graph, how is my work represented?
Area.
Awesome. Is it going to be, if I just chuck on some numbers here or some letters, which area under which graph are we finding? Which curve we're going to look at for an adiabatic expansion or compression rather, sorry. The bottom curve. Awesome. And how do you know that?
You're going from BA to BB and PA to PV.
Awesome. We're rapidly compressing, which means our volume needs to get smaller. So we need to go from A to B, which means we want to find this area, which means we want to know what the equation of this curve is. So we're going to try and use this formula to get that. Awesome. We also know, or hopefully we should know, what the work formula is.
Is it integrate? Like when you negative integrate P as B, B?
Awesome. Does anyone know, this is like, this next step is like the hardest part, and after we do this, we're chilling, but does anyone know how we're going to combine these two formulas to get onto the right track? Yes.
Replace P with the other values.
Perfect. So, sorry. Okay, so I'm gonna say that this leads me to P is equal to nRT over V. Then what I'm gonna do is I'm gonna take this bad boy, chuck him right in there. Chuck him right in there. And when I do that, I get my work is equal to negative integral nRT over V dV. That was the hardest step. And essentially what we've said now is that the curve over here is the function nRT over V. Are we all good with that?
What is N here in this question?
N?
Yeah.
Little n is number of moles. In the equation that I had before that you guys said you use less of, and P is equal to big N K BT, this N is number of particles. But you guys said you rarely ever use that, so don't worry about that. Yes.
Your V, are you gonna look for VV or VN?
Good question. Is this integral here finished? What do I need to add to it? My bound. What's my lower bound gonna be?
Yeah.
Perfect. And my upper bound? Sweet as. Do you guys know how to compute this integral?
Negative nRT LMB between the bound of BA and BP.
nRT ln. I've just done a lot of steps in one, and it's really important you guys know how to get to this final step. So does that make sense to everyone, or should I take it through step by step? So when we do a PV diagram, essentially, look back up to our favorite formula, this one. So we essentially want to find the work which is given by this equation here, and it says that it's some pressure over some change in volume. The change in volume in our adiabatic process is happening, right? And we want to calculate the pressure at every single point. So that's where we're going to use this equation, and we're going to isolate P so that then we can sub P over here. And then we have an integral where we have a V. Does that clear up the question, or should I try and explain it a different way?
Yeah, it's more clear now.
Okay, awesome, yes.
Wait, so heat is zero, right?
Now we're gonna talk, okay, if we wanna talk about heat, that's a different thing. For an
Adiabatic?
adiabatic,
Yeah.
it is zero, yes.
Can't we just say work is equal to the change in internal energy formula?
So you're then using, I think you guys write it like this, is equal to change in Q minus change in W.
Yeah.
Do you guys write it like that? Awesome.
Yeah.
If my heat for adiabatic is zero, that means that the change in U is equal to the change in W, or negative change in W, my bad. So then yes, the change in internal energy is the negative change in work. So you could do that. I'm gonna be honest with you guys, I don't remember how to calculate internal energy in first year, so that's why I did it this way. Do you guys remember how to calculate internal energy?
It's, yeah, change of T.
Is it half? Is it?
Little ends, yeah. Yeah, we don't have any.
Yeah.
How do you find
Change
in the question.
Change
No, I get that, but internal, there's another one if you.
Oh, yeah, I think
That's chief.
that's another one, yeah.
Yes.
Oh, no, sorry, it's coming, but with the VA on VB, is it not VB on?
So we're gonna start at VA.
Oh.
And we're going to VB. So our initial goes on the bottom.
Oh, wait.
But you, like, when you integrated, didn't you go?
Oh, lol, yes, yes. Oh my gosh, yes, thank you.
Yeah.
You should be on VA. Yes, good spotting.
Yeah, that's what I'm gonna.
Yes.
You go one. In part one as well, you know, when we did, sorry, I should ask this ages, but we did PVs, PAVA over VB, right? But we don't have PA, do we?
Who's the atmosphere?
Oh, okay.
Yeah, consider an ideal atomic digest gas piston.
So under here is actually atmospheric pressure, which is 1.01 times 10 to the power.
Oh, yes, it is. Yes. It's really important that we do clear up all these questions because this is the question that you see again and again. Did I see some other people's questions?
And this was the.
Or are we chilling? Chilling? Awesome.
And
Okay. So if you chuck in all of the values into here, you should get a value for your work. Yes.
Confirming, to solve for the number of moles, do you use like ideal gas formula?
If you solve for the number of moles, it depends what you get given in the
Like
question.
in this question, because they're not given the number of moles, we use like PV and NRT. Solve for N.
Not given the number of moles. Wait, you want to solve for the number of moles?
Yeah, because like we're trying to put
Yes.
work in,
Then
get
use
that.
this one.
Yeah.
Yes,
so then get N and then put it back.
yes.
Which value of PE is it? It's the final value.
Wait, which value of P?
P and B would you choose for finding N? Or would it be the
I
same?
don't think it matters.
Doesn't matter.
As long as you take the corresponding P for that, so you
Yeah.
say the PV from here or here, but you cannot mix them up.
Yeah.
You cannot mix it match.
But I guess it's funny because they.
Do you have any other questions?
Just pressure, right? And instead of like.
No, are we going to move on to part 3?
Yes.
Yes, okay, awesome. Part 3 is how much work is done if the gas is monotonic, not diatomic. Can anyone tell me what the difference between a monotonic and a diatomic particle is?
They pair in singles or pair
Awesome,
one pairs.
awesome. What does that mean in terms of air?
F equals 3 monotonic.
If it's monotonic, it's 3. If it's diatomic, it has 3 powers 7 depending on the temperature.
Thanks, Scottish.
Okay. This is the yeah. That's that.
Yeah. Oh, then no.
So how would I?
Oh, sure, it doesn't matter.
Oh, no.
So what would I need to do in my third part to get my answer? What would I need to do differently?
Yeah.
So we're basically gonna do the whole thing again, except for a different value of gamma, yes.
If we do.
Now that we have N, where do we have N?
Couldn't
Didn't we calculate n? Get the work.
Don't know how we would calculate. It's like, didn't we get, like, to get the work done on the gas, we did negative. VD over the.
I don't know what you mean.
The end would be the same.
No.
The massive
Yes.
Yeah, but something.
The value.
Yeah,
We solved to find the work down gas.
Wait, we were given the value of S.
We weren't, and you saw this.
It's like, yeah, your work, was negative NRT.
You've got PV and the arms, the T and R, the constants, things all gone.
So if we have like n from that, right, like we from that PV and RT, right?
Yes.
Then we'll part 3 times delta E.
But yeah, like you don't have to use that as part one, so. I feel like you could do part.
Yes, it would be the same, but it's got F changes still. Yes. F changes.
Basically just.
Sorry? Yes.
But I don't know.
Your value will change.
So.
Wait,
With T, but we don't have delta T.
so it's worth the same for part two.
Because it's like.
You guys do a calculation to find out.
It won't be because P.
No, you
also
find
in
n,
PV,
like the first, like B in.
because the
And then
value
you can
of
find
F changes.
Oh, B,
Yeah, so you literally gotta go all the way back.
It's
yeah, hold on.
But same approach that.
But when do you use PB?
So the left.
Well, because you use it at the end. So in the end, you get minus NRT.
Before you, I'm going to do the task.
Yeah.
Is NLT to get that sign and then you start.
Oh, no, sorry.
That was a good
You can use it. You
Yes, okay.
By 5 over 2 by 3 over
So it's-
you actually got.
Wait, when does something happen?
Work was the initially. Start
For a
by
month
as well.
then you agree.
And
Why is it?
Yeah, well, aren't you?
Yes,
Wait,
I do.
Because
PV gamma is gamma.
But R is the same when it's delta. The same as one.
It's not
Is
true.
true.
So the work must change.
Wait, why is gamma set?
Because autonomic means so I can do that
When you add.
one work into the other work.
Not like with the other.
Yeah.
It's just.
Yeah.
Oh, yes.
Sorry, you don't.
Genius.
This question was
Big brain.
Yeah, no, I think
I would have gone through the whole
theoretically, we don't.
process of like, are you serious? Like,
Yeah.
It's 5. How do you? I think
So like, take a look at it.
Okay.
That's with the different apps. Yeah. So that means that I can't actually.
You do it from the start.
Yeah, you start being negative when you wait. It's negative and. Probably that when you have sex, you can even.
Yeah, but instead, yeah. It's probably fine for. Do you guys want some more time to discuss, or should we just do more questions? Yes.
We go back in the past, how do we find, you understand?
How do we find
Yes.
N?
And then
Awesome.
use that.
Yeah, how do we find N as well?
Okay, perfect. I'm gonna go over how to find N right now. Finding N is super easy if we just use our best friend, PV, But what PA?
Any PV, or
Guys, can I just get a little bit of hush so I can explain this and hopefully you guys won't have so many questions and we can move on. To find N, the number of moles, we want to use our ideal gas equation and we want to just pick one of the points in our diagram where we have the information for it. So in this case, we got given PA and VA. We also did calculate PV and it's all given VB. But let's just use this point. So we have the point PB. This is going to be P. Oh my gosh, no, that's not it. Looking at the bottom curve, my bad. So this is VB and PB. We can use this point and chuck these values into this equation along with the T that we got given. Or we can use the one down here, which is VA. So as long as you use one of these points and use the values and plug it into here and then rearrange for N, so you get PV is equal to N is equal to PV on RT, then you can calculate N, and then that's what we can substitute into our N.
So volume have to be in meters cubed.
Yes.
Key statements the same, and the volumes are given. And not stay the same, it's N and T is the same, but V. How does the work change?
Because our volume is changing. If I look at this integral, my integral there is saying that my work is dependent on my change in V. And V in my adiabatic compression changes.
The volumes are given. You have to calculate new volumes.
No. So we have VA and VB, yes. We'll get to this expression. We also just calculated N, and then we'll just substitute everything into this equation and get a final work. Does that clear it up? Kind of. Do you want me to re-explain it?
Maybe if we solve part 3.
Solve part 3? Okay, awesome. Did anyone actually get values for either of these things that I could use? Yes.
I got 3.8.
For 1 or for 2?
2.
For 2, we got 20.8. What did anyone do part A? That's okay. Yeah, okay. Okay, I'll go through part 3. So do you guys want me to do the whole process again just so you can kind of see what we're doing? Okay, awesome. I'm going to use my data A. So I'm going to say PA is equal to N times RT. Sorry, let me just see what my values are. Where's my PV? 1.01 times 10 to the 5, 1.01 times 10 to the 5 multiplied by my VA, which is 2.01. Yes, the -6, awesome, is equal to, the N is the thing that I'm trying to find. Can someone remind me what R is? 8.314. Oh, that's it.
Because you're converting from liters to
Is that
meters
it?
cubed.
Isn't that just?
Yeah, but just, yes, yes, sorry. But that's it for R, awesome. And then what's my differential?
Isn't that down to volume cubed?
You need to cover the close.
So it's like, I was doing it
Well,
last night.
1 milliliter is 1 centimeter.
And it shouldn't be down to the negative either, it should be just to the power of.
Oh, sorry.
Someone chuck that into a
Yeah, sorry,
calculator.
-3. It should be to the -3, not the -6.
Someone just chuck in. Yeah. Like 2 more decimal places.
2.7.
Awesome. Let's just take that as being our value of N. Now, the next thing I want to do is, again, without my best friend, EV is equal to NRT. Sometimes I see it in my dreams. I'm not kidding.
0.0.
And then after that, I also know that my work is going to be this sad boy. Awesome. And now I'm thinking, damn, I've got 2 equations and I need to fix them up so they fit together and I can get something useful out of them. So I can see that I have a P here and a P here, and I'm like, oh, damn, I might just do this. So I do this, and then I just whip this guy into there. And I get my work is equal to negative integral nRT over V dV. And then I'm like, oh, but what are my bounds on this integral? And they'll actually be the same as before. I'm going to have VA because I'm going from VA and then I'm going to VB. And then I'm like, oh, damn, this is actually like kind of messy. So I fix that up by just taking all my constants out, doing my integral again with my bounds. 1 on V dV. And then if I didn't know this integral, I would cry. But I do know this integral, so I'm not going to cry. Do this, it's an ln. I'll do the long version just so people can see. It's VB minus VA. And then I also know my log rules, so I can just say this.
V or ln VA.
Happened again. Oh my gosh, oh my gosh, oh my gosh, oh my gosh. Now I can't use technology. This is VA. Oh my gosh. Okay. Sweet as. And then I plug all of that in. So I want to plug all that in.
I got the N 0.0.
My bad. That was definitely a me issue.
I forgot to say.
That's very good. 8.314.
Sorry, why couldn't
And it's
do, because we had the same equation from part 2, right?
What?
So like,
What's the income? 29 plus 22, 73.15.
Whoa.
James, you
One
want me to
more time.
I'm not coming.
2 point. What's that? Did I hear a value get spit out? Oh.
273.15.
273.5.
That was just.
No, no.
Oh, no, that's Kelvin.
Like a little dog, just like kitty heads.
For the volumes.
Oh, that's again. It's are they?
Oh, yeah, it's just a 2 point.
Elements up, yeah.
Division.
Why is the work done on the gas negative?
1481.
Convention.
Is the-
Convention. I can't remember what it corresponds to, but
We'll get a negative value though. So how come when we push on the gas when it's dirty, it's negative 2?
no wait, so I think it's the same thing in this.
The ln like flips the fraction, the negative.
It does.
So
So
it's VA on.
again, if you know your log laws, you'll know that this is the same as this.
So it's what?
Oh, the VB is
No.
lower than VA, so the ln's gonna be negative.
ln
VA is 2.01.
Inside the LN.
no, inside the ln.
But
That's what I'm
it's
saying.
The ln itself is.
Yeah, the ln inside. Okay, yeah.
I got 1400 joules.
I think it's 818. Okay, why are we on V is 2.0. V is. Sorry.
Thank you. And this is VA 2.0. Okay.
Oh, I did 2.1. Because VA is 2.01 liters. It's the diameter. Sorry, the one's gonna be. So where is that information?
Yeah, because you're like.
Negative.
It doesn't matter, let's make the negative.
That new information actually is wrong. We're supposed to at the very beginning.
It should be 2.01.
And we were supposed to start from
But it
here,
doesn't matter, just give me the negative.
because the gamma would have been different.
That's true, well.
Also, you guys.
Can we just?
But.
Values and volume, I still don't understand.
Yes, yeah, that's because I missed. In the very
Yeah,
first
but it's
question, we have to calculate PD.
I'm just waiting for my answer.
When we move from a 90% volatile to a monatomic, we change our value, change our value of PD, which will then change our value.
I have 2 boyfriends who like.
So it should theoretically change.
They allow a range of answers.
I'm sure.
It's like, they give you a DVM, it's like.
You guys want to try another problem?
Yeah, sure, why not?
We should move past
Sure,
this.
we should move on.
How does this one look?
I feel like we should. Okay.
Oh,
So
I think.
it's different.
Oh.
You get.
No, not disagreeing.
Oh,
So, yeah, I know. The old lady who likes to do the calculator again, so that's. I don't want to.
This one's surely easier. Oh, okay. It's not me.
Yeah.
I definitely did that wrong.
Yeah.
And you want to be more
Just like.
go away. Get lost. No.
Probably the first part. That one in the Wales guys. That one chuck something in the Discord.
I did, but it was
Yeah.
I guess oh no, I didn't.
I swapped out of that one, doing computing engineering.
What did you say?
No way.
And I couldn't like airdrop it
Oh.
to the laptop. I guess,
Which
is it
Better.
as well. Sorry, I'm revealing everyone's personal messages.
You learn Python.
Yeah,
Python to solve.
yeah, I realize that.
That makes
Very
sense.
helpful.
Are you doing physics?
All physics, but not.
Is this your Discord that you know?
Yeah.
Physics, sidebar.
Chuck it in there, I get it.
So
Chuck it in.
People are gonna think I have questions.
I've sort of done a couple of one phone.
It's
I'm
totally
very
okay.
dreadful at.
No, I know, like.
Yeah. I'm thinking like
Answer, which is funny.
the holidays.
I think my laptop might be available for airdrop if someone's airdrop.
Can I get all the lectures on
Yeah.
YouTube anyway?
Yeah.
If you want to let's see, but just watch the lectures.
Like Python is not very useful for hardware engineering.
UNSW Comp 111 lectures.
Yeah, it's just Python.
I haven't actually Googled it, but I assume.
Yeah. They're like,
I got it.
they're pretty good.
It's just the.
Yeah,
Yeah.
I'm trying to get into comp.
Just walk up to the exam, be like,
I look
at
it,
it,
it's just like,
I need to actually get in special.
yeah, I do it.
And in fact, you tell me how you, but I want to do my physics. So I can't do comp next term.
You need to shoot my
I
laptop.
lecture you.
oh, I should keep it trying to roll it. It's so hard.
Yeah, you have to. Yeah, it's like they'll just basically
I think I was involved in like the generic.
Be like what they give it.
Oh, the one we
Sort of like, I was involved in like a generic version.
But I did, I put in like, I did it kind of like,
So the whole
Something
time.
next year.
I just did it.
Yeah,
You can do it.
It's right next to
I,
yes.
well then,
No.
no,
Yeah.
I have to do that and elect. So,
It's just
is what we do. But I'm already shooting to investigate what how we use that. It's just the need to, I think the requisite thing is technically that.
See that.
The one that we just didn't.
No.
One that
Oh,
we-
question.
You can find.
Yeah, that would.
Why do we need
Oh.
to calculate gamma?
Call that
Gamma
code.
is used to calculate the pressure. at the-
Yeah, no.
It's changing.
You.
Oh, yeah.
Oh, maybe.
Oh, and
These are-
It's like what if the head.
Yeah, it's gonna say like if we're creating okay, where do I down?
I only go to 3 days a week.
Oh.
Very good.
Well, this one's gonna make you go 4 days a week, or 5 days a week. That's not with all.
It's a dark.
Well, currently I'm currently going 1 day a week. 1 day a week. Yeah.
Hey, don't you live like 5 years away?
I'm doing,
Dude,
yeah, 2 hours away. Oh, that's, sure. Okay.
Yeah, go on.
Guys, it's not a competition. Honestly, you guys live in sad lives.
wow. It's so sad.
Ready to go out the light rail is about 20 minutes.
The light rail.
Yeah, that's all.
And I mean, better than ones that.
No, it's not. It's not.
My dad's right.
No train is
Yes.
18 kilometers an hour on average.
Literally, I missed the light rail, ran to the next stop and caught it. Like, it's-
Yeah.
Okay,
They're mostly
party
just focused
people,
on-
physicists. This is our next question. That we have asked. Okay, so we're in our kitchen and we have an aluminium pot with this mass and it contains this amount of water. The pot and the water have been sitting there for several hours and are at thermal equilibrium with the room at a temperature of 20 degrees. We place the pot of water on a hot stove that transfers energy to the pot at that rate. And we leave it there for 6 minutes while we watch a video on our phone. While you're watching the video, how much energy is transferred to the system as heat? Does anyone want to really quickly spitball what's important here? MC delta T. What's that equal to? What's Q?
But power times time.
Look. What is my mass going to be?
0.6.
I didn't do that.
0.6.
Oh, that's true.
So in this question, we need to consider our mass. So the mass is going to be the mass of the pot plus the mass of the water. And the reason for that is because the water is going to be absorbing the heat, but the aluminium pot is also going to be absorbing heat. So our total mass is going to be that. We just need to watch out on how we do our calculation. So I just mentioned that there's two different things absorbing heat, which actually means instead of just adding the masses, multiplying it by a common C and a common delta T, we're actually going to be taking the mass of the water, multiplying that by the heat capacity of the water, and then multiplying that by the change in T. And then we're also going to add how much energy the pot absorbs, which is the mass of the aluminium multiplied by the heat capacity of aluminium multiplied by the change in temperature. Because we're in thermal equilibrium, the change in temperature of both of those things is taken to be the same. You can chuck that out of our equation. This is also similar to something you guys would have done in your labs. Do you remember that? Okay, questions. I think you're at first.
Because we know that P is changed energy on change in time. Can we just calculate Q by doing P times time? Like Q on that wrong.
You said Q is equal to PT.
Yeah.
Yes. You can do either way. One is obviously a lot quicker than the other. Yes.
Where does that come from?
What?
Q equals to
Because to what?
PT.
Okay, so power is equal to energy over time. In this case, it's heat energy because that's the kind of energy we're dealing with. So energy over time. If I multiply by time, I'm going to get energy. Just like seconds, right? Time, like you have to convert the 6 minutes as well. That's another important thing that was mentioned. We also need to convert our where is it? Our 6 minutes into seconds.
Yeah, you go. We're on 50 seconds. But if that's the case, I just do P times 2. Yeah. Yeah.
Does anyone get a value?
We're using this. What's delta?
You can use either formula. If you were going to use the first formula for some godforsaken reason, MAL is on your formula sheet. But yes, this is a lot quicker, and for the sake of the lab test, use that.
How do you use that perfectly? Because delta T is 0%.
Do we not know what delta T is? Oh, log, we can't use the first one. Yeah, P is equal to Q is equal to PT.
1.224 megawatts.
You got 1.224 mega is times.
Oh, megajoule, yeah.
Awesome. Did people agree?
Where do we get Q is equal to PT from?
Yeah, I still want to.
Okay, so
Yeah.
Because energy.
one more time.
Oh, it's just energy.
Okay, so
Yeah.
Q is the kind of heat that we're talking about. power is given as energy over time, or the change in energy over the time. To get rid of time in this fraction, I want to multiply by time. That cancels out. I'm left with the here. Does that make sense?
Why,
It's something called dimensional analysis, if you're interested. Yes.
why do you need a time over there? Like,
Sorry?
why do you need a times like this time?
Because power is equal to the change in energy over the change.
Oh, the change of energy.
So we want to multiply by the change in time to get back to energy.
Thank you.
Is that all sweet? Yeah. Awesome. Do we have any other questions? Sweet as. Okay, so we have our value for you. Moving on to part 2, we have during this time, what mass of water will be turned into steam?
Probably.
It's just ML.
Where the physics from? Sort of, yeah, sort of. You use that.
This one is like, you got it, you got it in mind, and all of it takes.
Still not.
Or you don't see his 100 there. So it's just the first one, but you,
Does anyone have a starting point?
Q equals to ML. And Q equals to MC change of the water,
Yeah,
right?
it is. Q is equal to ML and
MC delta T.
does anyone know the difference between these two equations? Yes.
I think the first one's latent heat and the second one's for specific heat.
Was it?
Yeah.
Yes, do you have a question or?
The different masses, aren't there?
For the aluminium and the water?
No, I mean between Q equals to ML and MCAT. In the first, wait, what were you asking?
I was asking, do we know the difference between the two Qs? Q equals ML and Q equals MCAT. So yes, one is latent heat and one is specific heat. Now, this is a really important question. What is the difference between latent heat and and specific heat?
It's for changing state.
Yes, and specific is
It's like how much energy to change it by 1 degree or
Awesome.
kilogram.
whatever.
Something like that.
Yes. So the latent heat is the actual energy that is required to make your substance change state. And I'm sure you guys would have seen like this graph as well, where it kind of looks like different steps. Have you guys seen that one? All the flat points are talking about our latent heat because it still needs to like get the energy absorbed in order to change states. And then as we're stepping up, that's the specific part. Okay, awesome. So for this question, what am I gonna do?
Just on side note, you showed that graph, right?
Mhm.
And when it's like flat line, that means it's when there's a change in state. And when there's a change in state, the temperature is constant, right?
Yes. Also, another little fun fact, you guys might think that 0 degrees is the melting point or freezing point of water / ice. It's actually even more special than that. It's called the triple point, and it's the point at which water can exist as a solid, liquid, and gas at standard temperature and pressure. Just a little tidbit, something you'll see in 3rd year, stat back and thermo. I'm just saying. So yeah, do we have another question somewhere? No? Okay, chilling. Okay, sweet. Going back to question 2, what am I gonna do? Yes.
Do we just takes the water to get to 100, and then maybe add the aluminium to get to 100, and then you do the rest of it is the mass of water that gets.
Awesome. Do you want to have a guess at what the whole equation is gonna be?
Mass of water, C water, 100 minus 20. Plus a massive aluminium, C aluminium, 100 minus 20. Plus massive the water that gets converted to ice times the latent heat of fusion or evaporation. Latent heat of evaporation.
Why do you?
And then that equals the heat found earlier.
It is like latent diffusion, evaporation. Wait, latent together. Wait, what's it called? Latent heat of fusion and latent heat of evaporation are different because they're switching between different states. So because we're doing steam, are we doing late heat of evaporation or fusion? Evaporation, because we are evaporating. Awesome. Where can I find all of the numbers that I don't know?
That's a nice
Formula sheet, love it.
So if you add all of like, is that like Q total equals Q specific Physoc?
Yes, because we need energy to make it heat up. We also then need energy for it to evaporate. And obviously the water is the only thing that's evaporating. Yes. It'd be real bad if the pot was evaporating. Real bad. Bad.
We're not going up the temperatures. That extreme. It's not even melting, so.
Yes.
You just, you calculate like MC delta T and MC delta T, and then you also kind of.
Yeah, it has to be like
And then you
1,000
have
degrees.
And then you could theoretically.
A few thousand degrees.
What's the change of state where it goes from solid to gas?
Oh.
That's the opposite way. So we're not kidding. What's decomposition is the other way, yeah. Are we all good to move on to the next question? What is part? So during this time, what mass of water will be turned into steam? Oh, yeah, we calculated Q. We know these masses and these specific heats. We also know L, it's on the formula sheet. So you essentially just rearrange this formula for M here.
Are they?
They mentioned that it's
It should be fusion. Steam, yeah. Sorry, do you guys represent that as MS?
Oh, that's what it says on the inspection, so.
Yes, then use that. My bad. Sorry, it is Friday, guys, and it is week 9.
Let's see how close I am.
Did anyone get an answer for MS?
I have a question.
Yeah.
Are these questions not bad possible? 1 through 1 plus? Okay.
Yes. I took this from, the 1131, 111 exam, but they're asked 1121. It's in there.
Wait, so I haven't done it.
The only reason
I really know what you're doing. I actually.
Yeah, but this question is.
It still will be because there's still stars.
We've done gas loading now.
That's why I think like the answer we did that tonight.
Yes.
It's no
Yeah, but you have an understanding.
And like, you could time it.
Don't get your.
I guess I'm gonna value. So I'm still valuing that every time.
No, that's the one that I sent you guys.
Why?
No, that's my second.
Oh my God. I've
You-
seen that in my
I've
life.
seen
Wait, did you send it on?
Yes, I did. Like, oh,
That's
wait, sorry.
Oh, yeah, no, I thought it was.
This is like here using.
Okay,
I have no idea where it came from.
Not that bad.
It should be in actions.
Yeah,
Okay.
that's a really important, like,
But it's
yeah,
not.
it's like stars. Is there stars like?
Like, you know how WAM is like weighted? Is it weighted against like business students, like more than the average?
Like something intuitively know, right?
It's in stars, right? I think that's the answer. Yes, except stars are 3D. This is considering a 2D star.
Yeah.
It gets like, I guess really excited. Yeah. Yeah, sorry? I'm doing like advanced.
More than one.
Oh, hi.
Why not? Everyone to the third half. Yeah. Yeah. Guys, can I get everyone's attention, please? Thank you. Moving on to part 3, or did anyone calculate a value for MS? We'll just pretend we did. That's okay. And we'll keep it in mind. We'll see if we need to actually calculate as part 3. So after the video is finished, you notice that the water is boiling and turn the stove off. The pot, including the lid, has a surface area of this and an emissivity of that. What is the net rate at which energy is transferred from the pot to the environment by thermal radiation? Anyone want to have a guess at how we're going to start?
Oh, because they're giving E.
A
You can just think about this equation.
times T to the yeah.
Is equal to?
The radiation.
Like that one. I don't know.
Like I was,
But now I fall. That's the log.
yeah, it was like
Well, we don't have like the density.
okay.
I think the letter is sigma, right? The first letter is, yes, it can be like the linear density. Oh, that's why they gave us the area. No, this part's. Who said that?
Me,
Really?
like, I've never seen that one.
That's why I was asking for. It is on our sheet, but I saw
Yeah.
first time like yesterday.
Yes.
In this question, this was the first time I looked at formula.
What did they use?
Did you guys watch your lectures?
Maybe.
I listen for every lecture and I still don't get what it means.
Oh, you missed my lecture.
Oh, sorry.
But we've been to everyone.
I'm still like, we've skipped lecture.
I just finished.
Oh, no, maybe that was really.
We would have skipped the lecture for Good Friday.
And this would have been it.
Yeah.
Revise it, guys. They only revise it.
I need to know more than that. Well, some people don't.
Absorption is
When I have the lab.
and
I saw that
then
was yesterday.
the like absorption.
So much anxiety.
As long as you guys are like kind of vibing at the same time, it's fine. It's fine.
Oh, yeah.
Yeah.
I want to drink eggs.
I never
Yeah, sorry.
Yeah.
Why does it assume that stuff like that?
Yeah, exactly.
Why do you think it?
Like me.
That's a good task.
Wait, this is
Okay.
It says at the beginning, it's given out 3 minutes. 1
It's
Oh, yeah, it's 5.69.
That I've just found on the phone.
yes, it is. It's like something bolted.
After that, you do it yourself. Calculate like. And that was all, sorry.
What else did it make?
I'm not sure. I don't think you do. I thought it is. You know, just like.
Really?
I think you're the only guy who said one. Oh, I've been revived.
Yeah, I said you were. I do, I'll send you. Yeah, I'll send you.
This is C9.
No, it's not only one lecture, there's 2 lectures in the week, but I mean, like, so many ones to read.
Everyone good. Can I just get
I understand what you mean.
Is everyone good? Someone's for different questions.
I'm just doing one more. Wait.
Does anyone have a suggestion for what question we can do next?
How do we do?
That's I'm doing one.
Do you want me to?
So we use the we special.
Yeah.
Is that what?
Oh, yeah, physics. Yes.
Oh, they just check their shit.
It's so nice.
What can you tell me about this?
What is regular physics?
Yeah.
Yeah.
So that's gonna
If I
be
wanna have.
2 hours.
Wait to.
Did you
take
look
one
at
day.
stars in the lectures as well?
What's another stuff?
Okay, because the stars, they use a different sigma and it's a 3D. They have to.
Yeah,
do
I
this
see.
with- So you know,
Yes.
we also use, surface area as well, that's why I like to.
You're high enough level 120. Because I didn't need to, because I just need rest of the.
Sorry?
And I just, I'm not gonna.
Sorry, hang on.
I want to do, fair enough. Everything you need to. Anymore.
Accidentally picked higher.
I feel like I should, but that's like make my, yeah. I don't want to redo anything on, right? Yeah. I mean, that's all I wrote down.
I don't know about.
This is my looking answer.
Genetic waste.
And that's the waves. Waves.
Little bit. Yes. And then like you can do the. Like. Yeah.
Do you want me to sign?
Like the class friendly.
Oh,
Like.
Wait, what's?
I do.
Like.
Oh, okay, yeah.
I'm doing like 17.
Yeah.
It's like, it's so.
But they it's so. No, like the concepts are really easy, like it'll be like,
1511.
you know, all the currents going into a node are equal to 0.
Wait, but surely, I heard that I physics 1A and regular physics 1A are kind that. So surely if I need that, I can use special one is like. Because I don't know anyone. So surely I'm not the super like. I don't need to do special. Don't do special. It's really exciting.
Can I get everyone's attention, please, again? It looks like we all have, guys, can I get some? It looks like we all have a whole bunch of energy in us that we need to get out. So do you guys want to take another 5-minute break? Please send over any questions that you do have to chuck it on your Discord or direct message anyone from Physoc. I put an announcement up the other day, so if you just click on my name and click direct message, you can send a screenshot to me like that. But yeah, let's just take 5 and I'll prepare some questions if no one else sends me. Does that sound like a plan?
Also, yeah, if you have questions, message this, like, are you in Instagram for this looks alright? Or if you have any like individual questions while she's going, just, or maybe. Oh, wait. Yeah.
It's just like.
Who wants chocolate?
Yeah.
Okay, we got 2 dairy milks and a shit ton over there. Okay.
Did you guys chocolate eggs? No, they just
Shit. Okay, so this underarm's going. Let's go.
That's good.
I've got 5 left. Okay.
I see any family in this room.
I'm not extending.
That's a lot
I can tell I'm not playing and that coordination form. I just got up when I was a kid. No, but I put coordination form. Jokes, we got that.
Like, I have that too. Yeah. I have like one 5-week. I have a it's on sign off.
Jokes still been pretty now.
Yeah, I know. It's still watch this back and think that was
Chocolates.
the one. I can have some chocolate. How do you do that? When I know. Oh, I trust you. I trust you.
Yeah, it's the one that
I don't.
Yeah.
Oh, it's so sweet. Should we all do this? I can't. Yeah, he's like, I'll work in 5 minutes. He's gonna be fine. Okay, wait, this time. Oh, yeah, time is. Wow. Oh, we can take the picture. Yeah, let's take pictures.
Are you typing?
Okay, here, please take the and sing something. Go. Ajax. Oh, wait. Okay, you literally put it on a 5 minutes. You wanna do that?
Let's just do this. But your head needs to. Where's my head?
I'll do it.
Okay, that's good. That's good. Just
really
like a
good.
bunch of like
Right.
Well, if you get made.
ladders.
Yeah.
Okay. Wait, hold your egg like on
I
the.
find that
Oh,
I always.
yeah.
Not because I don't have a confidence. I know.
I feel so opening for sure.
Actually, the exact same.
So bad.
My arithmetic was.
Oh, we make a funny face. Okay.
Make a funny face. I'm like, and we'll be like.
Okay, we'll make it. Okay. Funny face.
Yeah.
They're like.
Yeah, no, really. Yeah.
You understand? We get our technical approved every time.
We can use it. Maybe we can
But you bring it in.
Yeah, you can.
Okay, don't mean it.
I don't know how they. No, they don't. They make that. I don't know how like.
At least for this time, because they.
Yeah, that's what it says, but you're gonna be trained by this time. I'm pretty sure.
Me too. They drop everything.
Just put it on the like thing. But then.
I'm so sorry.
I really want to do all this.
I'm pretty sure.
I'm gonna look.
Oh, wait. There's a big.
Yeah, I know.
Okay, let me okay to me.
If you're able to bring in so many.
Why is
That was me. You can trade it. You can trade it.
So you do that.
I don't even know. It's just there.
Then you write.
Okay, right.
Remember.
Are you? And up into your back. Oh my god. Everyone. Oh, I want context. Yeah, but exam information on Moodle. Yeah, I looked at it on Moodle. Okay, this is from 2020.
Oh, okay.
Yeah, it's there.
Oh,
Just have all of your level and
Otherwise, like if you want to go to the beginning.
2021, that was.
What?
I wasn't even at high school.
Reading the most chaotic of all this. The three of us are so chaotic. Like, when did I try to like,
Yeah.
wow, I didn't realize that.
It was only like
After 9, after 10.
That's not like too bad. Although we were also out of school for half of the night,
But then it'd be like, building blocks.
Yeah.
But then it'd be like though, but then like throughout year scale, I would never go to.
Yeah, I was like. What was I doing again?
I am new animals.
Just check on.
That was
Yeah,
Always gonna have the last word.
Yeah.
Yeah.
What? Oh, Cadbury still did. Oh, yeah, they didn't have Cadbury.
Yeah.
Oh, yeah, bro.
Like, I look, how do we our assignments?
Yeah. Oh, I got.
I love it.
See, I reckon I did well, but I don't know if I did well.
I look at the cat, I look at the cat photos and I'm like, oh, like,
But they like document.
yeah, there's like a lot of info.
No, I did. I like.
Yeah. I thought I was failing. I take it back. This year you can't use it. Oh, I thought I was gonna fail. We can use that.
Opportunity for lots of MATLAB.
Right.
Isn't MATLAB just all matrices?
Yeah. It's like another.
Yeah.
Yeah, the course notes, because though you'd be able to bring in your own Greek math. They're just like maths.
I think that would be.
That's not nice. Like,
Oh,
yeah.
It's
I don't know why. It's not the one I can like for you. It's probably because I do. I get the point. So like you can.
Yeah,
Okay, actually.
That would have been a big.
Yeah.
I don't get it.
How do we do that now?
I think we want to do that. Yeah.
Oh,
I don't know how be like.
That's.
I know.
Yeah, I feel like I'm gonna.
Wait, who's coming to that?
When do you have your?
Oh, you're talking 29.
Actually, no, it's not.
And I get everyone's attention back to the front.
I think I saw this.
You coming to us?
Yeah, you might have.
I went 2.5 out point.
Maybe.
Can I please get everyone's attention?
I also need.
Awesome. We had a question come up during the break, and it's this one. So we have a frequency generator that oscillates up and down sinusoidally, and it sets up a standing wave in the string. The equation for the traveling wave generated by the oscillator is given by that, where x in meters and times in seconds. This traveling wave is reflected from the other end of the string without any loss of amplitude. Write an equation to describe the standing wave in the string. Awesome. So we get given this, which is our most important piece of information. Awesome. Does anyone want to have a guess? It's okay. Remember, I said that voltage was not volts.
Okay, I'm just gonna take a guess.
Don't even.
I'm gonna guess because it's sine cos. Usually that's like one of the identities, which is sine 2a, I think. And like sine 2a is 2 sine a cos a. So you probably have to multiply something in the brackets by 2.
Voltage is ohms, amps, yeah.
You're a good man.
Wait, what's the, no, actually, what's the unit for voltage?
Volts.
Okay.
You got that one. I got that one. Yes. Yeah. Okay. So what do we think we need to do? Yes.
Just add them, like add both of those together. And then use trigger.
Add both of what together?
Sorry, like the one thing, add 2 of those together. Create a standing.
Yeah, isn't it just sum of
Some of
angles, like the sum of angles?
and which angles are we summing together?
Like
Eight
that.
point four eight x negative 470.
Awesome, so I will change this. So you're saying we're gonna take 2 times y plus t? Is that what you're saying?
What?
Yeah, I
Just
try.
like the trig rule. Okay, yep, that's what I'm saying.
Trust me, I.
Well, you're just doing 2
definitely
times yx.
I think because of my ADHD. my
So I'm gonna take 2 times 3.71 sine. 8.481 minus 476.
Formulation.
In this case, it'll be minus.
No.
Is
Is that what we're saying to do? Is
Yeah, trigger it is, yeah.
that what we're saying to do?
Yeah.
But isn't that like kind of, sorry, totally wrong, but is that kind of implying that when you reflect it, your amplitude's gonna be double, but like, should it be double though? Cause like, I know when you reflect it, it's like this exact same, just in
Awesome.
direction.
Awesome. So let's go back to what a standing wave actually is. If I have 2 like modes, let's call them, what is my standing wave going to look like? Just a wave, right? Just some random wave, right?
Yeah.
In this first part, it's saying that this wave that's generated is also reflected back without any loss of amplitude, right? And equated to describe the standing wave in the string. So what might the standing wave be?
Oh my god.
Oh my gosh. Oh my god. So we think this is the answer. Guys, I'm gonna be so honest. It's 4:30. I don't know what's happening anymore.
Okay, we're gonna have to start from the top.
I just
What's happening? Where's the phone machine handy so I can?
Yeah.
Oh my gosh. I need a.
Give me.
I'm just gonna step
Thank you,
outside.
sorry, I was rude. Man, please have the phone machine, thank you.
Does anyone want any chocolate before I just?
Yeah.
Except for caramel and koalas.
Caramel. Yeah. Okay, this is my tentative question. It's gonna be all the time.
Oh, my bad.
Okay. A frequency generator that oscillates up and down sinusoidally gives a bit of a standing wave of things. Okay, all these worded questions, as I've seen before, Tom loves to fluff around with words. Just, we've seen that from that question that you showed me. Tom just likes to, yeah. All you know, a standing wave on a string. Don't read all words. This is not. Literature people? Do you want this one? Equation of the channeling wave is generated by the oscillator, given by that. Okay. That is what you want. Do I like the color? Yeah, I do. That's what we like. That's just all we care about. This traveling wave is reflected from the other end of the string without any loss in amplitude. Write down an equation to describe the standing wave string. Okay. Without any loss in amplitude means no energy is lost. Cool. It's being reflected on the other end of a string. Now, do we remember, have we done standing waves on a string? Yeah. There are 2 types. There's one where the end is loose and one where the end is not loose. It's fixed. Sorry. In one case it reflects, in one case it kind of inverts as well. Which one? I can't remember exactly. So which one reflects, which one inverts?
Inverse.
What was that?
Inverse is fixed, yes.
Okay, so inverse means it's fixed. So if it's just a reflection, it means we've got a moving one, right? Cool, check. So I'm just gonna write that down. I don't even know if it's even relevant to the question. Do I want to write it down? Yes, because I want to write down everything that is useful to me, okay? So we got not fixed. Can you not read my handwriting?
It's nice and neat.
Thank you. Thank you very much. Haven't got the same fever. Okay. What? Talking shit? In terms of sin and cos, okay. Stack marks negative answer as incorrect.
Oh, true, that's real.
I'm open to
Is I the
Write down, okay, write down a
I like the selected.
3 variable. L plus 9. 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 3
It would be x times e to the.
Okay.
It's like, it would just be one.
Funny.
I'm gonna risk you.
Okay, so can anyone search up for me a bunch of trigonometric identities on the internet? Just someone-
It's all
You wanna see?
Trig identity. Trig identities. Thank you. I got it.
Yeah, sure.
Oh, you.
Okay. Now. Let's see this thing. Okay. Does anyone remember from high school, like compound?
Nope.
Yeah, it's just kind of a problem.
Yeah.
I don't remember. So.
Can someone pull up?
What's that?
I just, I'm religious off things, guys.
Just read them off to all of us.
Yeah.
Okay,
Rattle them off.
so, you know,
Let's go.
sign of
It's gonna be some multiple.
There we go.
Yup. That one right there.
No.
Oh, they are.
Yeah, they're also on the.
By the way, I don't know,
But this
I don't
has
have
more.
solutions for these, so this is really just me like, on a free run, okay?
I ain't supposed to be in sign.
Minus.
So,
Plus.
Yes,
sorry.
Wait, shouldn't it be minus? I mean, sign.
It's the wheels of the stand, like. Like between front and down, they fit two.
okay, sorry, my bad, okay, new identity. Like, it's like, maths is kind of like a toolbox, guys, you just like collect stuff, you know? It's like, oh, if you guys like Pokemon, it's just kind of like Pokemon, just use it when you need to.
Oh, wow.
It's gotta catch them all.
Be the negative.
If you don't have them all, that's
What?
like, that's like the whole thing, is you're only allowed to carry a set.
That's what the analogy is. Okay, so we know this. Thank you. What's your name? What's your name? Okay. What's your name?
I'm running.
Thank you to Madame Curie. So we got sine A.
Not minus.
Equals to 2 sine.
Yeah, you're there.
I don't even know. Even my dad.
No, that's so fun.
You've never been. What?
Yeah, I don't know what's the. What the waves. It's just. You like something with the thing.
It's the same fine. I was trying to get the bear now. It wasn't.
And then if they can do this together. Yeah. But like, I haven't done it yet.
What is standing wave?
Yeah.
One from the left, one from the right. So you have to add the reflected wave to the super wave.
Yeah.
Oh, okay.
Yeah, this one's. It's not. You tear it,
We got
The grams.
I wonder why she got that out. Isn't it minus? Sorry, that's really bad. Isn't it plus A minus B over T?
Ryan, it's easier to see it if you just slide.
I saw that.
Wait, isn't it A plus A minus T? Because there we go, that's what you got the time.
3 hours of
Some people go. Going off there.
I thought that,
right here.
See, it says sine A plus sine B equals 2 sine A. That's one of the same pound A.
I'm right. All right.
I've been. Let's close that. I got double angle.
okay. Have you guys ever seen that before?
Yeah.
Yeah.
Yes?
Yeah.
Sweet. Okay, that means that's literally it. So we got, what's our K?
8.48.
Cool. What's our A?
3.71.
What's our omega?
470.
Sweet. So we should get that as the answer. That was like something like, so what's double 3.71? 7.42?
Yeah, was
Yeah, good. Sine of kx, that's the 8.48x minus omega 4, because then have like. It's the same, so we don't have to do any sort of weird conversions.
That's.
Is everyone comfortable with that?
Isn't it cause of minus
gonna get at least
over two? Like minus. I don't know if you use.
Oh, whoops, you're right.
But did that change what we did? I don't actually get the equation. How you went from the last one to the next. Like the one that's highlighted in green. Added. That added to itself.
If you got.
Yep.
everything
And then
that's above.
using the trig identity of sine A plus sine B. Yeah, no, that's, and then extra. Oh, sorry. So like, it'd be the same thing. Yeah. That's right. When you add them together, you get minus 470 minus just adding it to it. And it's plus minus 8, like.
Oh, no,
divided
that's.
by two, so you get plus minus 470.
Oh,
And then this. I think you're right. You think quantum compass.
Where
I think you're right, but.
is there like a?
You wanna write it down?
There's literally, there's gonna have Google it.
Yeah.
Those trig identities like half of what I want.
Yeah.
Just search up on Google trig identities. Yes, we're using that, because I don't know how it's derived.
That's literally it.
What's the divided to?
This one part to this.
Exactly.
It's just like.
Yes.
Yeah, I think you're right.
That's it. Thank you. What's your name? Zara?
What's sorry?
Zari. Okay. Zari's giving me this, so I'm gonna use this. Very helpful. Thank you, Zari. So, what we got, so we can think of it as, two ways on a string, one going that way, one going that way. So we can treat it as two ways, right? So we got one equation, y1 is equal to, we can just like make all this like,
So we're on the A side.
I can't make this smaller. Can I like decrease it?
Yeah, it's just simplify
Tap it.
the expression.
Right.
Okay.
Ah.
It's a matter of minus.
I'm just gonna make that just to help.
Yeah.
See, even pros don't eat love.
Well. Okay, so the reason why I've written this is because y1 represents our wave, let's say, going to the right. So we have something like, we have a diagram? Yes, we do. So that's that wave going to the right. And then the other wave going to the left, it's simply being reflected. So we just like put, instead of a negative sign there, we put the positive sign. It's going the other way. It's being reflected. No loss of energy is useful to us because that means this A is equal to this A. Cool? Everyone all good? Now, yes.
Wait, so when you're reflecting it, why aren't you putting a negative on the amplitude instead of the inside? Is it because you're
Good question.
the
Because it's just being reflected. So like flipping the amplitude, like putting negatives on the amplitude means you like inverting it. Yeah, exactly. Inverting it that way.
Okay.
While you're just reflecting, so you're just gonna want to go that way.
Is it like math, like FX?
Kind of, yeah. Yeah, you can kind of think it like that. And so they did Zari. Yes, that's in Cool. I'm remembering names. Okay. So we know y1 plus y2 is equal to, I'm just gonna do, a sine of kx minus wt plus a sine of kx plus wt. And what we know from, I'm just gonna enlarge this again because that was what we know from this thing here, look at that, we can use it. So we know this identity from our cool formula sheet that we all know and love and you rely on. We can write that as, where's my pen? 2a times kx cos t. And that is basically the derivation of that equation. Because the kx is and the wt get plus and add cancel each other out. Any questions regarding that derivation? Yes,
When you went the other way on the graph,
hang on 1 second.
it's like you went.
You want chocolate? Which one do you want? What do you, oh, wait, what do you mean? I just got them like 5 minutes ago. Shit! Okay. He's the only chocolate. Okay, cool. What was the question?
So when you're going you're going to the right originally.
What's that?
You go to the right originally and then back to the left. Isn't it just the same equation?
Not quite, because you can think of it as like. So if I draw like,
And then a study period.
let's just draw it like, instead of going like
Final
there and back, I'm just gonna put it like.
And then we get two
One
weeks.
going one way, going the other.
Oh, great.
So I'm gonna draw my sine wave. Is this?
It depends when
Is that big enough?
Yeah.
No, it's not.
Depends on your exams and it's too officially, but some people go through.
Is this? No, it doesn't make tornadic stretch.
3 weeks is so short.
So,
Yeah. 3 weeks.
this is my sine wave going one way, right?
2 weeks.
Yeah, choose.
Okay.
This is my sine wave going the other way. Now you see that like, if this is kind of like moved around that end, it's not going to be the exact same because like, you know, doing that, I'm doing that, you kind of get like a way, kind of like looking like that.
Yeah.
It's on the.
Does that make sense? So when you reflect it, it's not the exact same, it's gonna actually be like it is perfectly.
Have you booked it?
Out of phase?
Yeah. Maybe it would be.
I know, depends on the way, always depends on the way.
I think
That, this is just a good example, sometimes not.
So,
Does that make sense?
But you
A
can.
little bit?
It's W.
Because.
Yeah. Yeah, with the ideal gas.
You can kind of think of it as like moving forward, and moving backward. You just put a negative t on the t sign. So you can think of it as like going forward in time, going back in time. I like to think of it like that. Is that like the first thing to track? Does that make you guess so? You know so. If it works, it works. Okay. Do you still want more clarification? You sure? Anna can help you as well because.
I can.
Any more questions?
You want some more?
Yes.
I just had, if it was a fixed answer, then would you have both of them being minus?
A fixed, which one?
Like for the y1 and y2 back.
Yeah, there's one here.
Would you have the sign be the same for both of them when you add them?
Oh, like here?
Yeah.
Not quite.
What would happen?
If it was what? What would happen if it's fixed then? Well, yeah. Yeah, you might get a slightly different equation. You would. My math is not that good.
It's minus sign.
You can, yeah, you can just play around with the math yourself. It's always good way of learning. But I think what would happen is something would happen with either here or something would happen here. I don't really want to go through it all now because we probably all have burning questions to ask. Yes.
I get that like y1 was the original equation and y2 was the reflected, right? But why did you add them together to get the standing wave equation?
Good question. Because, okay. If your iPad dies, I'm going to be very cross.
If they're opposite, if they're like that, it would be closer.
Good question. Okay, so let's pretend that there is like some sort of board. A board with a fixed wave on. So I'm just gonna like move that red line over there. So you're gonna get like, it's gonna go travel like, it's gonna travel like there. People online, you can't really see me doing there, and there. So I mean there, and there. That'd be probably better for people online. So going backwards, you're gonna put like there. Right? Now, the reason why we say we want to have the equation that's described as standing over the spring, Because a standing wave on the spring is actually, I'm gonna use a big word here, superposition. If anyone doesn't know what that means. Whoa! Don't throw words out like that. No, it's just like, when I mean by superposition, I just mean literally just adding two waves together.
Wow, fancy.
Yeah,
You just said
using
that.
big words. That's a first because you can use big words. You're just adding that wave to that wave. Is that making sense?
Oh, that's the standing wave.
Yes, exactly.
So standing waves are just adding two waves together.
Yeah, pretty much.
Is that the one that looks like the
Depends which one you have. It's moving, it's not moving. I mean, maybe one of them might look like it. Although that's actually got to do with. Are you talking about like things where it's got to do with like
loops?
you have like
Standing waves start to make.
Yeah, it's like some harmonics.
that's like that's harmonics. Yes, which is kind of similar. It relates to it.
Wait, with the harmonics, sorry, that's a bit of a sidetrack, but with the harmonics, how do you know what's first, second, third?
It's got to do with the like you know how you have like
Like that.
yeah. So it's got to do with that. It's that end. Okay. Any more questions? You guys have some questions? Hopefully they'll- Any unanswered questions? Yes.
If you want to straight back,
No.
hang on to it until the end.
Why?
Just like yeah, they call it progressive. Has that.
You know, we've got a whole person in the lab doing all the lab stuff. Like, in my, that's not gonna be asking me to, you know, that's not.
We're all good. Yes. Yeah, look, I drew this very poorly, which is positive. That red line, we just go, yeah, that line, I should grow that in like, you know what? It's not actually a perfect superposition, because when you literally add this case, that solid red line and that blue line, in reality, that minus the VV just means a different point in time. Yeah. Does that make sense? So it's not like the diagram's pretty bad, but that was used to show that it's really so like we have two different waves on the same place the same string. Yeah, does that make sense? It's just it's not actually like it's not actually gonna look exactly like this. It might be a bit offset, so you might not actually get perfect reconstructive interference if you know what that means. It's not just gonna stop to zero. It's gonna stop to zero. Any more questions? I just write the people like maybe can't hear me.
See 1/4 wave is.
A diagram. Any more questions? I'm not an artist, so it's the best drawing you're gonna get. Any more questions? No? No? Cool. Okay. Yeah.
This says in the feedback, to divide it by half of a wavelength. What's half of a wavelength?
What? Here?
No, like below it, like it says divide the length of the string by half of a wavelength. What's the wavelength again? Phase wavelength.
So here, the number of loops is like C, like if it's one wavelength. Yeah. That's 2 loops.
Yeah,
Half a wavelength is 1 loop.
Yeah.
One wavelength is 2 loops.
Also, you eventually divide it by 2.
Yeah, because like
So it's 4
Gonna
pi
have, like,
over the thing.
you're gonna have like
Then use K.
yeah, you can have like a standing wave of a string, something like that thing. And That I guess it's west. Just think of it as like a technical problem. You wanna like, like, yes, it's not laying the string of half a wavelength. It's one of this.
Each way. I've done too many times. You know, and just think about it like it's step on it. When did we look forward? It's like, what's the thing? You can have like, you know, I've got like, no, only, wait, don't just.
Bro, you can open it if you need it, okay?
I've got. I just want him to speak on the house, like, well, I don't have that many bookmarks, but I have all the. You might zoom it out, just so I can see the patch.
I know you guys know my name. It's very hard.
What's your name? Maybe.
Your name is very hard.
My name is Bentley. Just call that Ash Bentley. Sorry, guys. Ash. Oh, let's see. We got the way. I'm trained.
You get that question answered about like why.
Because of wavelength.
Yeah.
So then you divide it to find and
Yeah, exactly. It's like wavelengths like that.
Sure. And then so that would be k equals to 4 pi.
So we get divide the wavelength string by 2 by half a wavelength. In that case, we're just going to fall like this.
And then you. It's very successful.
Does that make sense?
I mean, I did some questions.
Wait, so k will just be 4 pi over that.
Some questions.
So that's like
2 pi over.
so 2 pi over lambda and then divide by 2. Which is
Well, that.
Would it be k equals to
Yeah, it is, but like, I don't know exactly.
It's an another number of antidotes. Yeah.
No,
So do you know lambda is like the.
Yeah, I know, but then you just like you just divide by 2 to find the number and lambda.
It's not pure.
I mean, they don't even.
Although he probably.
3.33 meters. Wavelength, and you have a 3.33 meters. So you have 5 wavelengths. 5 wavelengths times 2 and. I'm pretty sure you divide the lengths by the wavelength. Surely don't know that much. It's the best thing to get.
Makes sense.
I think I get it.
Yeah? If we get it?
$1,000.
So I can explain it.
But I'm not doing it with the. I'm just saying like if lambda. It's gonna give you a wavelength. Like let's say it's gonna give you like either half a meter, right? And then.
Because
I guess it's better than Physoc. Yes, so I'm actually using
Yeah, but it depends on the number of hours. Okay, so no, they're really. Think about
In this question, the reason why they're using K is to just find the wavelength. And then for the wavelength, divide the string, length of strings on the wavelength.
Yeah.
And then I'm related to us. All good?
I guess it depends on the teams, like. I haven't like.
I'll just think that I that's the question.
Is this question done and dusted? We're all good.
Yeah.
Last time?
With everything.
Wait, why is K?
Yeah, that is not what I got.
Wouldn't K be 7? No, 14.
14?
No, K is not 14.
I'm good.
I got 0.
I got K. It's the number of wavelengths.
I don't know. I can't find the driver. I don't know.
I believe, yeah. Yeah, the number of wavelengths.
Oh, yeah. I think it's able
Okay, so on the 14th harmonic, who knows how many antinodes there would be?
Nine.
Oh.
Harmonics 4.2.
What was that?
Nine.
Oh, no, it's an antinodes. One knows.
It's like nine.
On the 14th?
Oh, no, sorry, part two is not.
Sorry, antinodes. Antinodes, number.
Oh, yeah, that's right.
7?
Nine.
What was that?
Nine.
Nine?
Part two.
No, part three.
So you're finding blank?
So, yeah, so we want 14th harmonic.
Oh, I don't know.
I haven't gotten that far.
Right, where on this formula sheet is the chord?
I was on that far.
The wave.
Real.
It should be on the page. Right?
Is the first harmonic one?
It
depends on if both ends fixed or just one end first. That's the first time.
I thought one.
Wavelength.
So then
And-
14 harmonic, that's 7
Like the
wavelengths.
over-
The units to the or it has.
Oh, the wavelength for the that harmonic.
I love how you barely.
So for the end harmonic. But I like for make sure
Yes,
that
yes, fair enough.
the right time. So
Yeah.
maybe.
Harmonics was 9
No
meters
one
in
is
height.
I said that I'm trying to see that's like it's I'm like it just like really I miss like messages and it would come like
Yeah. Correct.
45 messages.
Yeah.
It's on the phone. Oh my god, actually that's
It's 1:30 in the morning. I'm actually that's
Doesn't seem to think so.
yes,
Then technically.
yeah, I'm like
These are
Yes.
Oh, these are
Wait, I would never turn down the opportunity to.
Yeah, this headphones. What do you mean? I want to get them, but I'm.
Yes, are you serious?
Yeah, I'm confused. Okay.
Yes.
Finding antinodes for harmonics.
Yeah.
Oh, yeah.
What do you do? Does anyone know? What do you do to find the antinodes for harmonics?
One harmonic like starts 9 bosses, so it's now.
What?
Did you say antinodes or nodes?
Antinodes.
I think antinodes. I thought it's.
Antinodes are the ones that don't. Right?
I'm like an hour.
Antinode.
Antinodes.
Okay, so we know
There's like all the
each wavelength provides 2 antinodes. Cool, right?
Yes.
Yeah.
Cool.
And then you just use that.
14th harmonic. Okay. 14th harmonic. So when we have each harmonic is like, so when you get every harmonic's what, like 2 antinodes more? Like,
Is that even?
yes, we were discussing this.
Every harmonic has one, that is the first harmonic, that has one antinode.
1 antinode.
It's also in a closed space.
I thought antinodes this. No? Wait, shit.
The nodes are the things that don't move.
These 2 things move, right?
Those move.
So those are the antinodes, yeah.
Those have 2 nodes. There's 2 antinodes.
So that's the first harmonic.
Which have 2 antinodes.
Antinode
It has 2 nodes. One antinode.
Where's the
Oh,
antinode?
yeah.
The antinode is the trop. Or no, the amplitude. So the. Okay, so I think.
No. So,
We're done.
You are aware.
are you good? Want to take over? Don't cry.
My body is so high, I'm not even doing this.
Okay, so what's
Look at skinny man, that's how we feel. First year, we just got out.
someone has a good definition of an antinode? The antinode, you were saying.
Where it's moving its peak, basically.
It's peak.
So the greatest amplitude, that's
Oh my
the.
god. That
So-
is That only has one antidote
Yeah, no,
because it's.
I
an
know.
antidote.
Well, who knows?
I do know how to do it.
Got it.
Each way.
Yeah.
Got it.
So that right there is half a wavelength. And that's one wavelength.
This makes us feel better.
So.
Yeah, at least, yeah.
Yes.
The guy that died, okay, this is.
Dominate's about to be mad.
Where's the, where's the one marker? Let's get it. There's one over there. One over there, come on.
Yeah. Actually, no.
That's so you, though.
These are not what happened on
Yes.
I'm
gonna go to the roundhouse.
Let's go. Problem. I don't know when this is
Yes, we
going
can
to
go to the casino. No.
Okay. Everyone cheated.
Really? I'm just so good at poker. Yeah.
Okay. If we have a flow.
Okay, so we got the casino afterwards now.
Okay, I hate this. Wow. No,
Guys,
if we have a flow so
give them the big.
like first.
No, I'm just like, no, we'll play some of this.
Like
Okay,
like that's equivalent half
Sit down there, so we go.
half of one wavelength. If I then want to find my second harmonic, I need two half wavelengths.
Which is one wavelength.
This is half of the wavelength, this is my second half of my wavelength. Similarly, like this as well. Oh, kidding. That's like, and that's four antidotes, right?
We're gonna let it.
We have a couple people here actually.
Just think of the nodes.
Yeah.
I don't know what antidotes are. There's one comes from two nodes.
Two nodes.
Okay.
Okay, 10 minutes. We're gonna have
Harmonic.
maybe four shots by then.
How many half wavelengths?
Three.
Half wavelength, another half wavelength, another half.
Maybe I'm you got to cope somehow.
Like this.
Okay,
Yes, yes, that's third harmonic. That's the question.
I'm not going to.
Let's just count them. Do you guys know what an antidote is? It's the one that it's the one that moves around. So four harmonic, how many half wavelengths? Four. One. Two. Maybe three. Four.
Wait, I know, surely there's an easier one.
They said each wavelength has two harmonics, so you would assume that it's compressing the top. Each wavelength has two
I'm
harmonics.
sorry, antidotes.
Okay.
Sorry, antidotes. I meant
Each wavelength has two antidotes. Yeah. This is one wavelength, so this must be an antidote, and then this must be an antidote. But I don't know what second wavelength, this must be an antidote, and so must.
Four of those,
But then what about?
and then the board doesn't taste like salt.
The one that goes upside down.
What cup plus cold?
I'm sure they mean.
We don't know. We do one of these questions on the.
Wait, why would you just do 14 times half, 7, then, 7, then, then 7 times the wavelength? That's
Three wavelengths. Yeah, just that.
It's 14 times half times then.
What was the question?
How many antidotes and 14 harmonic?
Yes.
I asked
Five to
a
10
similar one in class yesterday,
And
we
then-
were both confused as well.
I'm assuming, look, I'm assuming from what I remember, 2 years ago, so roughly, each harmonic would have two antinodes.
I don't think that's 7 lambda.
Every harmonic.
Sorry.
Every harmonic would have like, where's my pen? I'm not flashing this.
No, it's probably the white. That's right.
Drop that right.
So, This one has 2 antinodes. One there, one there. I know. It's another way to-
Yes.
Oh, it's two different ways. That's exactly right?
Yeah.
So this one has 1, 2.
What was the
three,
conversation?
four.
No, I was
This
saying
one-
double the harmonic then.
Yeah.
28 antinodes.
So yeah, so 14 harmonic
Okay.
Harmonic.
You just like.
should have
And that's like.
28 antinodes.
Because you're
Yes, that's what I thought. Now, fact check me, guys. Even on the last one. Fact
I
check.
found a question, but this is making me so.
So many
Yeah.
Yeah, thanks so much.
Oh, yeah, you should fact check, you should fact check me, because, you know, that would be
Thank you so much.
so good. I was trying to explain it before, but I'm like,
I'm gonna end the meeting online, so the recording's gonna stop recording, yeah?
Okay, so you,
good to
wait, what was the answer to the last question? It's not 28 antidotes,
28.
not to ask for the length.
28.
antinodes, and then we know
So the offering.
that.
Someone's getting. No, like.
We have something like that, right? Or like.
Okay.
This is
That,
the
right?
third part that we do this again.
No, I did.
Wait,
Yeah,
so-
I did this in class
We had,
yesterday. We were like.
yes, certain number of antinodes.
Oh.
We said it was
You said if
the
you.
length over half the wavelength.
Thank you so much.
Right.
I've just done like.
Wait, so you say that your firm harmonics is equal to.
Thank you so much.
Yeah.
Do we need to move the tables back down?
No,
Okay, good.